Hi guys, hold it for yourself.
All you see me and introduce ourselves and then go back.
All right. So we're ready to go. We're good.
Yeah.
All right. All right. Good morning, everybody. Sorry for the technical difficulties. For those that have been battling through this, I'm kind of split myself here where I'm looking at the screen, we're looking at the audience here. But thank everybody for getting up early this morning and joining either webcam or physically. We got some pretty neat things going on in the power energy sector that we want to get introduced to everybody. So we're going to kind of start off this morning by introducing our power team. And if I can get this to advance, that'll bring up the team. So I think Larry's been lining you guys up. All we want you to do is come over. You're not going to see yourself. Introduce yourself to the. No, everybody else does. You won't see yourself.
Good morning. My name is Israel Pipkins. I'm an inside sales engineer here at Vector, and I've been here for about 2.5 years.
Go.
Graduation. Good morning, Blaine Self, Vector Controls. I'm our project pursuit manager. About 7 years in oil and gas, 3 years here at Vector. I cover all of the territories from north to south and help with EPCs and projects. Thanks.
Jeremy Wilson, outside sales. Cover Baytown, Altamont, Bellevue. I've got some accounts in Pasadena, Deer Park, and Texas City.
Good morning. Michael Whitehead, compressed air specialist. Cover majority of the South. Been doing this for about 10 years.
Max Schiff, outside sales with Beaumont, Port Arthur, Golden Triangle area. I've been with Vector for about 2.5 years, in the industry for about 16.
Craig with a K. Cover some of the Beaumont and Port Arthur areas, Deer Park around, up into Conroe, kind of all over the place. I've been in the industry for about 15 years.
Hello, I'm Blair Sullivan. I've been with Vector since 2012. I'm in the greater Houston area, focused mostly on analyzer solutions.
Joel Hendricks. I've been with Vector for about 5.5 years in the projects group. I'm the project manager. I've been around analyzers and
All right, guys, did y'all hear the folks when he passed by and introduced themselves? And then we lost audio, or did we lose all of that? Now Boyd's muted.
I think we lost like maybe the last 4 or 5 people there. I think I'm unmuted now. Now you're muted again.
Okay. All right. So sorry, we're not going to introduce the remote team because obviously this is not cooperating with us. We'll run through the agenda real quick. If this will advance. All right, so we've kind of done the introductions of our team. We'll get to the introductions of the presenters in just a moment. I won't go through the names right now. We'll have a break around 8:35-ish. We're going to take about 10 minutes in there. So everybody, let's try and stay focused till then. And then we'll do that 10-minute break. We'll come back in. We'll do our last external presenter. We'll talk about Salesforce.com, some of the IIR information that we have, some of the KPIs that Larry and I are working on. Nikki will update us on a bunch of marketing material that she's been creating for us and putting together. And then we'll wrap up with questions and answers for anybody that's got questions for the leadership team at Vector and or for the external presenters that were gracious enough to spend their time with us this morning. Let's see. All right. Hey, that one actually worked. So this morning, instead of just being Vector presentation, we got 4 guest presenters that are going to be presenting for you guys. Boyd Coleman with Anderson Hauser is going to get us started. I'm not going to go too deep into their backgrounds because we're going to give them a second to introduce themselves. Matter of fact, I'm going to let y'all do that. Boyd, why don't you go ahead and introduce yourself and give everybody a little bit of your history. And we'll just kind of work our way across the slide from Boyd to Jeff to Dan to Dave, or vice versa.
Sure. So I'm Boyd Coleman. I think I've worked with a few of you in the past, but I've been with Anderson Hauser about 2 years now, coming up on 2 years this fall. Can you hear me?
Yes,
We can.
All right, sorry, I didn't get the hand signal. Yeah, I spent the first decade of my career as a nuclear engineer working in power plants. I went back, got my MBA, then I have spent time with instrumentation companies with Emerson and now here, and with Fluke in the middle. I'm the industry manager for power and energy for Anderson Hauser. So I'm in charge of solutions in the business, basically, for all of our both electrical utilities and industrial steam are kind of lumped together for us.
All right. Jeff, you want to go ahead? Nikki?
Sorry,
You're good.
can you hear me?
Yes.
Okay, great. Sorry about my picture. A little dark because the sun hasn't come up where I live yet. So I'm a little behind you guys in a different time zone, but I've been in the power industry now for about 35 years. I worked for Thermal Scientific. I've been with them for the last 8 as an analyzer and analyzer systems specialist. I've worked with Vector now for almost 1 year, and I sell products into the power industry.
All right. Dave. Dave, we might have you muted. Nikki, Dave is unmuted. Dave, we should be able to hear you.
He's not showing any video or any voice at all.
Dan, we might have lost Dave. Can you go ahead and maybe introduce yourself and maybe even just tell us a little bit about Dave? It sounds like he might have got disconnected. Dan Marquis is muted. Can I unmute him?
No, he logged in a different way. Audio.
Ooh, has to do this. All right, so I can see Dave.
Skip Dave for now.
Well, I tried to skip Dave and go to Dan, and you're telling me I can't do that either.
Can you hear us?
Dan Marquis, can you hear me?
Oh, I'm unmuted now.
Okay,
So I
awesome.
see it.
I don't know, for whatever reason, maybe we weren't getting Dave's audio. Can you just go ahead and introduce yourself and Dave real quick?
Sure. So Dave Horlocker, who will be doing the presentation, has been with CCI going on 14 years now. Had varying roles with respect to engineering, is it now in our application engineering group. And he helps a lot of the sales folks with presentations and doing this type of training, that sort of thing. Myself, I've been with CCI now for 34 years. So I'm had varying roles within the organization, pretty much all in the sales sides of the business, worked in power and oil and gas. So again, with the 34 years, the last year or so has now been a director of sales for new channels to market. And so looking very forward to working with Vector and the team. Looking forward to an exciting future.
Great, thank you, Dan. All right, so if we get to the next slide, Boyd, we're back to you. And I guess we're just gonna have to give Boyd full presentation and let him run the presentation from his machine, Nikki.
We don't need to see his picture. You should be able to.
Boyd, I'll just click through and then we don't have to do anything is what I'm told. So when you take a deep pause at the end, I'm gonna assume you're done with a slide and I'm just gonna advance us and if I
All
need
right,
to kick back.
that'll work. All right, so I'll try to make up a little bit of time here. I have a tendency to talk fast when I present, so if I go too fast or talk too fast, slow me down, you know, at any time. So if you just want to go over to the next, so just real quickly, what I'm going to cover is kind of size up the opportunity in vector territory. I'm not going to spend too much time on that. I don't want to be the person who, you know, looks at the past for a long time, but kind of where we are and where the opportunity is. Go over some key applications, and then what I really want to focus is the key applications and those questions to ask. So how to have the conversation, or, you know, who to talk to, and how to pique their interest, or what, when you hear them talk of a problem, you have that solution in mind. So if you go over to so this is kind of where the industry is moving right now. Sorry, this is a build slide. I want to just click through. I think you have to click 3 times. Thought I took all the build slides out, but that's all right. So if you look at what's happening in the industry right now, the biggest trend is getting rid of fossil fuel plants in order to reduce greenhouse gas emissions, and we're replacing that in the US mostly with combined cycle plants and with renewables. So it's about 50% combined cycle and about 50% wind and solar. The big opportunity for us, of course, lying in the combined cycle gas plants. If you look at that upper right-hand corner, what that shows you there is new plant additions and retirements. So we're right in the middle of this trend. We have about another 5-10 years. If you look at the bottom half of that, that's old coal plants basically that are getting taken offline and being replaced with natural gas. So this basically leaves us with 2 things. Number one, you can see new plant construction is pretty high on the top side of that, but it's not high enough to make up for both the expansion in electrical usage and for the retirement of coal plants. So the plants existing are being ran harder and longer, which means there's a lot of turnaround opportunities and there's a lot of aging plant opportunities there. And it also means there's a lot of opportunity in new plant construction, probably for the next foreseeable future. For at least 10 to 15 years, there's going to be a building of combined cycle plants like we've never seen before. There's actually more plants being built right now than any time since the end of World War II and the electrification of America. So that's a good thing for us, right? Spells opportunity. And then if you just look, I think I looked at Texas here alone, where the electricity is coming from. You can see that coal-fired plants are the 3rd biggest. Sorry, the screen's actually a little bit small on mine. But if you look at the bottom, non-hydroelectric renewables, which is wind and solar, is a good chunk. But natural gas is the majority of the power supply in Texas, and that holds true actually for Oklahoma and Kansas and stuff in the rest of your territory. So that's really where the opportunity is right now. The other thing to look at is the gas turbine plants are getting old enough now that they're starting to go through the MRO phase. So a brand new power plant, there's not a ton of opportunity for the first 3 to 5 years. Then after that, you start getting to MRO cycles and the opportunity kind of picks up. So we're really at the sweet spot where there's still more construction and there's some MRO opportunities available. Then if you look nationwide where the opportunity is at, if you split up, this is instrumentation across the regions where we split up the Anderson Hauser business. Vector's territory actually has the biggest opportunity in the entire United States. So there's $138 million per year that's spent on instrumentation in your territory. I think right now we're selling about $5 million a year, $4 to $5 million a year, depending. So we're growing actually pretty rapidly over the last 5 years, but there's a ton of opportunity out there. So we have less than 3% market share right now in the industry.
Boyd, yeah, the question came up that your slide here is just showing power and energy markets, right?
Yes, this is only power and energy and only instrumentation.
Yep. Thank you.
Yep. And then if you look at how we've been performing, so this is right now this year. So if you look at 2020, our MRO business has actually overall in the US has slightly grown. So we're actually up 3% in MRO, which is pretty impressive right now, given the current state of the economy and everything. So there is opportunity there. We still are winning MRO business. And so that's kind of the hot hand right now in Anderson Hauser, one of the hot hands. If you look at the project business, even though all of these gas turbine plants are still going on, we're actually kind of in a lull. Well, we're bidding a lot right now, and in the beginning of 2021, those orders are going to start coming through just because of the construction cycle. And the industrial steam kind of follows industrial output. So that part of the construction business is, or that part of the project business is down this year. And so that's leading to being 70% down in projects this year. So that's really where we struggle. There's plenty of opportunity there, especially on the generation side, probably more so than the industrial steam. And the also reason this is down is because the turnarounds have really taken a hit. There's been a lot of delayed maintenance and a lot of delayed turnarounds. So we're looking at 2021 as being a really big turnaround year. So that's one thing to focus on next year is when we talk to utilities, look at their turnaround schedule. They're going to be doing a lot of maintenance and they're going to need a lot of work. So there's going to be a lot of service opportunity out there second half 2020 and 2021. Which leads us right into calibration capabilities. So one thing with calibration, when they go into a turnaround, calibration a lot of times is at the end of the turnaround schedule. So they'll take out their equipment, they'll replace it, they'll put all the equipment back in and the instrumentation, they'll have to calibrate it before they get up and running, which means they become a bottleneck at the end of the outage. So that's one thing where we could really help them. Also our calibration trailers, especially with flow. If you look at the natural gas flow into the turbine, for instance, that's one thing they have to do a lot of turnarounds. So being able to help with that and being able to do a flow calibration on site really makes that calibration go quicker. Go on the next slide. Looks like we're in the middle of technical difficulties. Maybe, should I keep going? All right, I'm gonna keep going. Hopefully you guys can hear me.
Yes, please keep going. We're trying to fix it to where the screen's bigger for everybody, Boyd.
All right. I just wanted to make sure I wasn't like talking and I was the only one who could hear. All right, so I think most of you are familiar with our SMT-70. This does a couple of great things for our end users as we talk to EPCs and NG plant operators and utility operators. What they lack right now a lot of times is a single place where they can go look at all their instrumentation and they can have all the DMTs and drivers all in one machine. A lot of utilities and power generation stations are still doing their calibration with pencil and paper. So they'll go out, they'll send an army of people out there to calibrate. They'll do it all by pencil and paper. They'll go back in, they'll upload that to a computer. So this leads to a couple of problems. Number one, there's transcription errors as they move that, as they write it down and then transcribe it over to computers and to tracking systems and into their EPC. It takes, or their maintenance tracking system. It takes a while for them, or there's a lot of opportunities for error there. And it also is hard to for them to track where they are on the schedule, on the outage schedule. So they don't have that real-time update. They have like an end of the day update, or maybe even end of every couple days, they have an update of exactly where they are. So that's one thing that the SMT 7D install base audits can really help them out with, along with just the increased manpower of having people come in and do calibrations, because often they don't have the manpower to do that. And that's one place that Vector and Anderson Hauser can help. Go forward a slide.
Boyd, can you give
Yeah.
us give us like 2 minutes here, or
Absolutely.
just to get this video back up?
Guys, real quick, local guys.
I think that's more thing to do.
Can we ask Boyd a question while you're waiting?
Bring it.
Yes, please.
Okay, so I was interested in, you're talking about the trend to more combined cycle turbines. But my question for you is, and I worked for GE during 98, 99, and 2000. We put a lot of simple cycle turbines in. Are you seeing upgrades for those simple cycle to combined cycle turbines? Or are you seeing new grassroots plants with brand new, 2-on-1 type configurations?
Great question. So we're seeing both. We're seeing new plant construction that's just greenfield from the bottom up. We're not seeing as many, I don't think, simple cycles going over to combined cycle, but we are seeing a lot of like they'll take an old coal plant and they'll take out the boiler, the coal boiler, and they'll put a turbine and a Herzig in place of that, and they'll use the same steam turbine and steam system. They'll just have a new combined cycle plant attached to it. So there's a fair amount of that. But I don't know if I've seen taking just a simple cycle natural gas turbine and then making it a combined cycle. I'm sure it happens. I haven't seen
Yeah, if I could comment on that, we see that a lot in Latin America.
Yeah.
There's a lot of simple cycle plants that were built in Latin America, and there's a lot of conversions that are going on down there. That seems to be the mode of operation. They'll put a simple cycle in, and then they'll look to convert it later on to a combined cycle. Not so much in the US though, but I agree with Boyd as far as the coal side, how to utilize the same steam turbines in the coal industry.
Thank you.
All right, we back up. Looks like maybe.
Right there. Oh, you just.
Yes, you have controls now, Boyd.
Oh, okay. Let me. Okay, I'm not seeing how to advance a slide though. Oh, okay. I think I got it. So the other thing we can do as Anderson Hauser is this is kind of a play on being a main instrument vendor. That term doesn't always resonate with EPCs or end users. Sometimes, being a master distributor is a term they're more familiar with. So I kind of use those terms interchangeably depending on what resonates with the audience. But basically, we can do a tailored plan for any sort of project turnarounds or new construction. We kind of, I think, have had a tendency to think of this a bit myopic, looking at new construction and big projects, but there's no reason why we couldn't use that same concept and the same skill set that we have in order to perform turnarounds for people. So I don't want to spend the whole time going over MIV, but we can very easily tailor that type of concept to a turnaround. And we've been talking to some EPCs that perform turnarounds. And like I said, NG, which is a company that operates utilities for institutions, universities, or utility companies, and they're interested in talking about that too. So that's something that has resonated quite a bit. I don't think we've got there where we've actually performed one yet, but it's actually raises good conversations and is a good talking point and something that we could, I think, grow in the future. Okay, now I can't advance the slide. I'm not sure how to go to the next slide, guys. All right, so some questions to ask if you just want to go to the next one. So talking about having the manpower to perform calibrations coming out of outages. So that's something, of course, we can help with. We've talked about the database of instrumentation and having the control over your turnarounds and your turnaround schedules. That's something SMT70 can help with. Having all the DTMs for all instrumentation suppliers inside of one machine, that's something really big. So you can go out, you can have your technicians in the field, you can have all the calibration equipment that they need, all the calibration procedures rather that they need with them to perform all their calibrations, and then it automatically gets updated into the calibration schedule and to the outage schedule. So that's something that really helps end users, especially, like I said, coming up next year where there's going to be such a heavy turnaround schedule. This is something that could really help people out. And really what the people we've talked to, they're really interested in is being able to come in, having turnaround schedule help. So bring in an SMT7, put an installed base audit, doing all the instrumentation, and then at the end of that outage, we turn over the SMT70 with all of that inside the machine. So that helps them not only with the current outage, but it helps them with all outages going forward and gives them a better instrumentation calibration schedule or program. So really big for customers. The other thing to look at is heart-baked verification. Of course, we're the only people in the industry that can do this. So as we all know, there's 3 pillars to heartbeat. There's the diagnostic, verification, and monitoring. So I'll kind of focus on the verification for today. So the good thing about our verification, or where this helps our end users, is a couple of very important calibrations. If you think of the flow calibration for natural gas going into a turbine and the flow calibration for the stack that are both needed for regulatory purposes. If you look at natural gas flow in, that's something that if they have to take that flow out of the system, put it on a flow skid and calibrate it, that's I think they're moving to every 6 months. The EPA wants them to do that. So if you can extend that through heartbeat verification, that's a huge win. Number one, it keeps their plant up and running longer. They don't have to bring it down just to do that, or sometimes they have multiple strings. But even if they have a multiple in parallel instrumentation, that's a big point of leakage. So the less times you can break that seal, the less times you can go through all the mess of bringing that out of the system. That's a huge win for them, and that's something people are very, very keen on doing. So if they can go with a heartbeat verification for one of the cycles and extend that to a year rather than every 6 months, that's a big win for our end users. And that's something, like I said, only we can do. That's a highly differentiated solution. All right, so pretty easy questions there. So if you just get them talking about the process of calibrating the inlet fuel flow to their gas turbine or their boiler, anything they can do to extend that calibration cycle is going to be a big win for them. That's money directly in their pocket. But then if you talk about how's the calibration done, what would it mean if you could extend that period? Those are the big talking points of what if you could leave it in there and you could do a heartbeat verification instead of a full calibration, bringing it out and extend that cycle. All right, so the next one to talk about is gas phase compensation in the steam cycle and level measurement on the pressure vessels. So if you look at the big places for this in the steam cycle, if you look at the boiler drums, the high pressure heater string, and the feed water tank. If you look at, we'll just kind of focus on the boiler drums. The traditional way to do this is through DP. So I talked to a lot of utilities, especially combined cycle plants that were built with DP level control. The problem is if your level goes too high, you'll end up getting vapor down your main steam line. You get it into your turbine, which leads to really bad things into your turbine. As you can imagine, those steam droplets hitting a turbine that's rotating at 10,000 RPM. If you go too low, then you can uncover steam tubes. If you uncover steam tubes, then you have real problems in your boiler. either your boiler or your feed water heaters inside of your HRSG, your heat recovery steam generator. So what the problem is, a lot of people don't know whether they have wet leg or dry leg in your DP cell. So if you don't refill your dry leg as you come up to pressure, you'll basically have flashing of that steam leg. Your level indication will become erratic, and you'll have automatic plant trips, or it's just a scary situation, just not being able to see what your steam drum level is as you come up. So that's something a lot of end users have problems with. Of course, the gas phase compensation and guided wave radar gets rid of that problem. So you don't have to fill the wet leg. You don't even have to know if you're a wet leg or dry leg because there is none. You have direct level measurement. However, if you go to the next slide, that does introduce a new problem. Radar speed is changed by the density of the steam. So if you have dynamic gas phase compensation, you can actually compensate for that. So you have a reference rod within the transmitter or within the detector, which will detect that known length. It'll see how long it takes the radar to travel that distance, and it'll automatically compensate the level for that. So if you look at the bottom, if you look at how big that air could be, if you're up to pressure and level inside of your steam drum, you could have up to 75% air in that measurement, which is fine. A lot of people, if you don't have dynamic gas phase compensation, what they do is they just take the full steam and they compensate it manually. The problem is, where you really have problems is startup and shutdown. As you move throughout that steam bubble, and as you go from atmospheric pressure up to 2,000 psi or 3,000 psi, that is constantly changing. So what you need is to have dynamic gas phase compensation. So during startup and shutdown, when you have problems, that's where you have it. So it gets rid of all the problems with DP cell or with DP level, and it gets rid of the problems with going to gas phase compensation. And normally what people do is they wrap this all up into one a bridle that's got a magnetic level indicator with a gas phase compensation. So anywhere you have a sight glass, you'll be able to have flippers here. So you can easily be able to see what level is visually. You have independent way to see both remotely and locally what level is. So it meets all of the ASME guidelines in order to for your gas phase or for your level compensation on your pressure vessels, which is big. All right, so the questions to ask, it's really focusing on maintaining steam drum level on startups and shutdowns. That's really where the problem is, and a lot of people have this, and every gas turbine that's been built in the last 5-10 years is experiencing this problem right now. So going in there with the solution is really a big one. So you want to talk about how they're measuring a level on their steam drums, whether they have wet legs or dry legs, how they fill the reference leg on a DP cell, because most of them have wet reference legs and don't even know it, so they're not filling their reference leg, which is leading to a lot of these problems. And if they do fill it, it takes scaffolding, it takes a source of DI water, it's a pain in the butt. So it really makes their life easier, this whole solution. And then of course the sight glasses, once the sight glass gets old, you can't see through it after the first year and a half. You get a bunch of crud buildup in there, and the magnetic level indicator solves that problem for them. I just want to go to the next. All right, there we go. So the next thing to talk about is fuel flow to the boiler or gas turbine. So depending on what type of boiler or turbine, we have, of course, a full array of a flow measurement going into that. We talked about heartbeat technology and why that's important to this measurement. The other thing to talk about is the onboard gas engines, which is really big if you're running a turbine or a boiler, especially if you're using some sort of flex fuel where the combination of gases within that are changing. So if you are running a natural gas, Coriolis is a really great measurement for that. If you're running a boiler, you might be using something as low as the i300 series, or something a lot bigger if you're running a full-blown gas turbine, that 500 megawatt turbine. But being able to have an inline viscosity measurement, Coriolis flow, and detecting water in the oil, and then of course integrated gas engine, which we'll get to in a second, are really big there. If you are running a boiler and you're running of course, biogas, for instance, being able to use the prosonic flow and getting real-time methane fraction analysis is really big. That way they know how much methane is. Then the thermal mass flow meter for either smaller boilers is a big one too. The common thing here is having that inboard gas engine. It not only gives you flow, but it actually gives you knowing the breakdown of what gases are in there. It can give you the thermal content of that fuel. So if you're looking at what is the thermal efficiency of our boiler, our turbine, you can actually calculate that, because you not only know flow, but you know how many BTUs are contained within that gas. So you can actually do a better calculation on what your efficiencies are. Of course, on-board gas engines, what they allow you to do is you load in there what the mixture is of your gas, and it'll give you, there's 20 gases available. So when we say natural gas, that's actually a mix of all sorts of gases. So if you know all those gases, you put them into the standard gas engine, it'll actually spit out, okay, what are the gas conditions? It'll look at what the densities are, and it'll be able to adjust for that and give you a actual accurate measurement of all the gases, the gas mixtures, the BTU content, and give you better control of your boiler or your gas turbine engine. And it actually is a good way to back up what you're being charged from your whoever you're buying the gas from. So a lot of people are using that to kind of check their bill and make sure they're getting what they're paying for. So I'm trying to go a little bit fast here to get us back on track. We weren't all that efficient at the beginning of this, so I'm going as fast as I can. So the other thing to look at, another application we have, or another product that really has no equal in the industry, is the ProLine ProWhirl. So being able to look at wet steam quality and wet steam measurement is a really big one. If you look at this for sub-metering within the plant, for custody transfer, if they're using some sort of where they're using their boiler both to create steam for use or to sell and for electrical generation. So if they're doing some sort of cogen and they're selling the steam, what this does is it looks at not only what is the steam flow, but it looks at the quality of the steam. So we know that steam holds about 10 times as much energy as water does, or water vapor. So as that steam leaves the boiler and starts to condense, this will actually measure what's the steam quality. And again, it'll give you the BTU output of what that steam is. So you actually know how much BTUs worth of steam are going someplace, rather than just what's the flow or the mass flow or volumetric flow. Now, a lot of people do this just by assuming 100% steam quality. So they'll look at pressure and temperature, they'll look at the chart, they'll see how much energy is contained in that steam, but that's really only valid if you're at 100%. So every time you go down to 80%, it's going to have a lot less actual energy within that steam, so it allows you to measure that. The other thing it does is it allows you to protect your plant from any of the problems that low steam quality causes. So it'll protect you from water hammer, protect you from having well, it won't protect you, but it can give you an alarm to let you know where you have a condition that you have saturated water in your steam. The other thing it's good for is desuperheating. So it'll let you know if you're actually having enough cooling water to get your superheated steam down to saturated steam conditions. So not only can it measure how much subcooling you have, it can actually measure how much superheating you have. So in some places in the plant you don't want superheated steam, it can actually give you an alarm and make sure that your desuperheater is operating correctly, and let you know if you have superheated steam somewhere you don't want it. So both of these put together. So if you have a better way to measure the BTUs in your fuel, and you have a better way to measure the steam quality and energy of your steam, you put those both together, throw in a memograph, advanced data manager, and you could actually do a much better job of measuring the boiler efficiency of your steam plant, either boiler efficiency, or if you go to the next slide, you can actually measure the efficiency of any of your plant equipment. So if you've got heat exchangers out there, anything that you want, that you have been doing a mass balance on, you can actually now do an energy balance on. So you can know how efficient your equipment's operating. You can better plan your outage schedules. You know when to clean heat exchangers, when to bring them offline, when to go to the standby, when to backflush it. You can just have more insight to how your plant's operating. And really, the enabler for that is the wet steam measurement and the fuel flow measurement. So kind of questions to ask is, you know, when you look at the components of your natural gas, so if you have a plant that's doing, especially if they're dual fuel, if they can use diesel fuel or natural gas or biogas, there's plants that can do that. So how do you switch off? How do you know what the fuel composition is going to your boiler, and how do you know what the efficiency of your boiler is? Same thing with a heat exchanger and feed water heaters. You know, how do you decide when to clean a heat exchanger? How do you decide when to do maintenance on it? When you come into an outage and you've got all these thermal equipment in your plant, how do you decide what to do, what maintenance to do on what? This can really give them insight on when to do that. And then, of course, how do you know when your steam quality is too low? This is a lot of problems, not so much in generation, but especially if you look at industrial boilers, knowing when your steam product goes too low, and cogen plants too, is really a big problem, because people just assume it's 100%, and often it's well, not often, it's not 100%, it's almost never 100%. As soon as it leaves the boiler, it starts condensing the second it starts going down the pipe. So knowing what that actual vapor fraction is a big deal. I think we covered all this. And I think the last one here is ProMag. So one of our brand new, one of our newest things that came out. So looking at the full bore ProMag electric mag fuel flow. Sorry, just got a, you guys can still hear me, right? I just got a pop up there saying something. All right. So full bore fuel flow is a big one, especially places that are looking, like we were talking before, a lot of plants are upgrading. They're going from coal plants to gas turbine plants, and a lot of overhauls and a lot of work being done inside of power plants right now. One thing that people are looking for is upgrading instrumentation in general, and flow is a really hard one. So if you're looking at feed flow, if you're looking at flow to your main condenser or to your condensate system, being able to put in a new mag meter there and not have to worry about straight run piping is really big. So that allows them to go to upgrade their instrumentation, upgrade their technology they're using, and not have to worry about all of the re-engineering of all of their pipes within the system. So that can be a really big one for people who are doing plant upgrades. Yeah, pretty easy questions there. You're just a conversation about where they're looking at upgrading their plant, and I think you guys know mag meters are and straight run piping. I don't know if that means that much explanation for you guys. Then the last thing is looking at the portfolio we have for analytical. In this case, analytical means something different to everybody, but we're talking about feed water chemistry here. I'm gonna go forward. So the new one we've came out for, or the first one, is MemoSense. So if you talk about our MemoSense technology.
Hey, Boyd, real quick.
Yeah.
Sorry, and I ended up messing up the world again, but on the new zero DIN mag meter, does it give a conductivity output as one of the options?
That's a good question. I'm not sure. I can definitely check.
I'm sorry. I promise I wasn't trying to stump you. I had somebody ask me that, and I go, ooh, I don't know. I'll ask Boyd.
Yeah, I'm not sure. I mean, that's an easy answer to get. I can get for you easy by the. I'll tell you what. When we get to the question period, I'll come back to that answer.
Okay, I should have waited. All right, let me get you back to presentation. We're here.
Oh, no worries.
Wait, sorry. Nick, we may need you again. Oh, there we go.
Don't touch anything else.
Yeah.
All right, Boyd, back to you, buddy. Are we in the right spot or we need advancement?
No, we're good. Actually, advance one more. There we go. So if you look at all of the sample steam, we have a very robust analytical portfolio. Unfortunately, we don't do a ton of business in analytical. I'm not sure why. We have the everything that our end users need for their feed water chemistry. I think it's mostly honestly an effort thing. I don't think we've tried to sell analytical that much. But a good time to get in there right now is with our silica analyzer. It's really better than the competition, quite honestly. That's where we have good talking points. It's where we can actually win business. So I think the right way to do that is lead with silica, sodium to a lesser degree, but silica, and then try to dovetail everything behind that. The other thing we have is the MemoSense technology. I'm not going to give you a whole analytical thing, mostly because I'm not an expert on it, and because I think you guys have looked probably at our analytical, and you don't need that baseline of knowledge right now. We can definitely get that at a later date, obviously. But if you go to the next one. So for MemoSense technology, of course, we have pH, ORP, conductivity, dissolve oxygen. Really, the big ones in the power industry are pH and conductivity. That's used in a lot of places. Having the MemoSense technology, of course, everything that comes with it, with having the brain stay with the actual sensor, being able to flip that out, do calibrations without taking it out of the process. All of that, of course, is a huge step over what people are doing and having that real-time measurement. The other one I want to focus on, because I don't have that much time left, is the silica. So silica is a real big problem in power plants. It gets introduced to the power plant actually through the water treatment. So when you start to have your ion resins break down, it'll either get through the groundwater you're using as your makeup water for your steam system, or it'll actually do a breakthrough and get released from those from the ion beds. The problem with silica is it stays in when it's in steam and it's hot. It actually stays in the steam, but when it starts to cool down, it'll plate out on material. So the two places it generally plates out is on your steam turbine blades. And if you can imagine getting a buildup on that steam turbine blading, leads to imbalances, it leads to a lot of inefficiencies. So it's a problem with having that on your steam turbine blading. The other place that'll plate out is on your heat exchanger. So as it cools down on your feed water heaters and stuff, you'll get that plating, and it's almost like silica sand, right? That's what you make glass out of. You almost get like a glass coating. So all of your heat exchanger surfaces are going to be really compromised. Our Liquiline silica analyzer is actually much better than the competitors. The two things to talk about here are the dispenser pumps. So there's basically two places to dispense. You have the hydrostatic pump, and what a lot of our competitors do is they use that in a timer. So you have pressure, you have a timer, a valve opens, and then it shuts. The problem is this isn't a very accurate pump, so that timing uses too much, too little of the chemicals too often. What we have is the hydrostatic pump actually makes the pressure, and then you almost have, I think we call them precision dosage. Forget what the exact linear drives, individual linear drives. Basically what it is, it's a syringe. So that syringe is actually very accurate in dosing. So it does a couple things. It gives you more accurate measurement, and it loses a lot less chemicals over time. And the other thing is the physical layout. So some of our competitors actually have this pump that's mounted right next to the electronic circuit board, which, if you can imagine, having water in your circuit board mounted in the same place isn't the best of ideas. And then some of our competitors are forcing end users into very long, drawn out service packages that they don't necessarily want to pay for, or they're avoiding the whatever. They're avoiding the, what do you call that, if your instrumentation breaks? And
Warranty?
yeah,
You can,
Yeah,
we're
so,
not.
yeah, so that's getting void unless they go into long service packages. So there's a lot of opportunity right now, both from the way our competitors are acting and the design of the silica analyzer. It's pretty highly differentiated right now, and people are open to making that change. So that's a good way to lead.
The question, Boyd, was who's our competitors? I know Waltron, Hawk. I mean, those are the guys that I commonly see, but who else?
Yeah.
Who else is it?
So the big one is Hawk. I think what's happening right now in the industry is Hawk is kind of waning for a couple of reasons. And the big question is who's going to kind of come in and fill that void. I think the big competitor to fill that void is Swan. I think we're seeing Swan a lot.
We just, and by the way, Boyd, our group has a lot of background in analytics. We have a lot of guys that are full-time service guys around the analytics, but not in silica and sodium. But yeah, we do see Hawk, Swan, even the city of Houston job. We ended up subbing about $200,000 worth of Swan analyzers because the customer, had experience with them. And we were surprised. They're newer, they're lower cost. Hawk is higher cost, but you're right, Boyd. People are looking for an alternative to Hawk.
Yeah.
Even Ken up in his territory had a alkalinity analyzer, and they're trying to look at something other than Hawk. So,
yeah.
Go ahead.
And honestly, I think the one advantage Hawk still has is basically relationships. I don't think they have an advantage anymore as far as equipment and service and how responsive they are, but they do have a lot of relationships.
Go ahead.
All right, so this is kind of things we're doing right now you might not know about. So we did do a webinar series. I put all the links here. You can go through, you can look at it. It's mostly industrial steam based, but that a lot of the applications translate directly right over to electrical generation also. We've been doing a gas phase compensation webinar. That's mostly been internal for sales training, if you will. It's a really short half hour, and we're in the process of making that end user friendly, which basically means we need to get some pictures that we have permission to use outside of just friends. For the first time, we will be having a booth at PowerGen in 2021. It was supposed to be 2020, but it's being pushed back to I think March or April. So we will have a booth there. It's going to be in Orlando, so not too far from your neck of the woods. So anybody who wants to come by and see PowerGen and help us out there in the booth, that'd be great.
Boyd, I'll probably be there, so keep me in the loop on that, please.
No, it's not approved.
Who was that? I don't.
Dan Abaird. Don't listen to Larry.
All right, Dan.
I know.
All right, Dan, I'll definitely keep you in the loop.
Thank you.
Yep. Another thing we have right now is we're actually making pretty big strides with Kiewit Power, Gemma, and Black & Veatch. We actually haven't done any business. Gemma Power, I'll tell a quick story there in whatever little time I don't have left. We haven't bid a project for them in like 10 years. They're actually coming back. We bid a project recently, and we've got 2 more on the horizon with them. So we're actually being invited to bid projects. We're being, I think, have a good chance of winning. We have more projects in the pipeline right now than we've ever had. The other ones look at in your territory, Kiewit and Black & Veatch. Our relationship right now is leaps and bounds ahead of where it was this time a year ago. So really exciting things happening on if you go back to the beginning of the presentation, I was talking about the new plant construction, gas turbines. Those are the big ones right there, Kiewit, Gemma, Black & Veatch. They're doing most of the plant construction, and we're getting cozier with them and getting asked to bid, and I think we've got some good things coming up there. And I think that is all I have. Oh yeah, focus on the big thing here. A lot of potential out there. We've got $5 million worth out of 138 million. So good timing. It's a good time to focus on power with big outages coming up. We've got some competitors that are waning. Even we talked about the analytical side. Even if you look at the Emerson side, they've cut back $300 million in the last year of investment in the company. So they're being able to not service anything other than their A players. And having worked for Emerson, I can tell you that power companies, none of them are their A players. So they're not servicing their power companies like they used to right now. So great opportunity for us to invest in this industry.
All right, thank you, Boyd. Excellent presentation.
Thanks.
All right, Mr. Jeff, Boyd, actually, you made up pretty good time for all of our technical issues. Still pretty close to being on schedule. Mr. Jeff Harrington, are you with us and ready to go?
Good morning. Can you hear me okay?
Yes, sir. You have the floor.
All right, we'll figure out how to bang through the slides here in a second. But Boyd, I want to say that was a very nice presentation. I was real interested in your fuel flow meters. You know, we often use those as part of the systems that we're going to talk about here in a minute. And the other basket of products you had, I thought were pretty amazing for the power plants. I want to know, how can I get a job there? Looks like a good place to work.
I think you'd have to take my job, which wouldn't be that hard. So don't do that.
You put the bar up pretty good this morning.
So who's changing the slides, me or you?
If you can, you're more than welcome to. If you struggle with it, when you pause for a moment, I'm gonna jump ahead.
Well, try one.
Okay, I'll do like this. I'll go like this or something and change the slides. Just want to make mention on that last slide. Of course, I'm with Thermal Scientific and I'm with their analytical division, and we're manufacturers of gas analyzers and analyzer systems, generally for EPA compliance, for air quality. So we're talking smokestack emissions, but we'll also talk about some process measurements that are made along the way, particularly with pollution control equipment and then combustion control systems that are still used in some of our older technology. We didn't talk a lot about coal-fired power plants, but thermal's still big in the remaining ones that we have out there. This slide here is an example of some of the instrumentation that we make. Our factory's in Boston, Massachusetts, and so we've been around since about 1974. Since the EPA first started making regulations associated with air quality, we've been in that business. Our business started with a couple of Greek guys who built analyzers in their garage for Ford Motor Company, doing tailpipe emissions. And then the entire company now has been built basically on the back of our gas analyzers. Thermo right now at this point is about $25 billion a year, but most of that is life science companies, pharma, biopharma, and solving the coronavirus. Let's see. Can you advance a slide for me there?
Yeah, I thought you could for a second. That's why I was leaving you alone, but okay, I got you.
Yeah, I didn't know how to do it. I was hitting the arrows there, but that wasn't doing it. And I didn't see anything to click on. So if you, I'd appreciate it. One of the big products, one of our flagship products, is a mercury monitor, and it's a system that measures mercury. And I said I had a place in my heart for the coal-fired industry. This is strictly for coal-fired applications, both cement and power, but there's a lot more power plants in the country than there are cement. I like coal. I've been in the coal business since 1958. That was the year I was born. And I remember driving to my grandparents' house and getting out of the car and smelling the old coal-fired boiler that heated their house. And I've been in love with coal ever since. So Thermo has made its living on the backs of dirty industry, but as we're going to talk, the transition's being made more and more toward the gas-fired stuff because we know that that's the future. Next slide, please. Just an example of some of the equipment. What the last slide showed what you might find down in an equipment shelter, in a control room, in the instrument shack. And then, of course, our systems are drawing gases out of the smokestack itself. It's reporting on what's being exhausted into the atmosphere. And this is an example of what a probe might look like up on the stack. This is probably up at the 300 or 400 foot level at a coal-fired power plant. And this the physical interface. Yeah, go ahead. Next slide, please. We're not going to talk about this drawing. I just want to give you an example. This is how a system might look. So we have some gas analyzers. We have some probes on the stack. We got some heated transport line to transport those samples down to the analyzer shelter, and then all the subsequent quality assurance stuff that goes along with it, calibration gases for daily cal checks, instrument air for purges and zero checks, instrument air cleanup systems, so on and so forth. This all ties in then to a PLC or a data logger, which then does some tricks where it might interface with the plant DCS for combustion control, or it might interface with a reporting data system that generates those reports that then go to the EPA. Next slide, please. There's my baby. Look at that. I love that right there. That's how it used to look in the old days. Big clouds of belching smoke and megawatts like crazy. So that's all going away. I'm afraid that we're going to see the demise of the coal industry, and it's too bad. I lived in Kentucky for years and years, and we had the cheapest electrical rates in the country, all because of 60 and 80-year-old coal-fired power plants, TVA, and so on and so forth. The real advantage to coal, though, is it represents a lot of opportunity for us. So within a coal-fired power plant, there are multiple places to find our equipment. And so Texas still has quite a bit of coal-fired power, lignite-fired power, and this is representative of that. So we might be looking at the stack for the final emissions going out for the determination of compliance with the air permit. But we also might be looking at inlet-outlet for scrubbers for SO2, where we might be looking at inlet-outlet configuration for an SCR for NOx removal. We might be looking at ammonia slip on the downstream side. So that picture right there represents a lot of opportunity for the thermo analytical products. Next slide, please. So where do you find gas analyzers in a power plant? Well, these days, gas turbine power, that's the big thing, as we talked about earlier, both in simple cycle and combined cycle plants. My question had to do earlier with the upgrade of simple cycle plants to combined cycle, because that is also one of the triggers for the EPA required equipment. So simple cycle turbines often have a low load factor. They just run as peakers and generally aren't required to do some of the rigorous testing and monitoring that combined cycle plants are. And so my question had to do with whether we're seeing simple cycles converted to combined cycles. And of course, that is the trigger then for the systems that I sell. If you see on there, some of the things that we monitor, gas turbines, NOx, nitric oxide, and nitric dioxide, CO, carbon monoxide, oxygen. Those are very typical, but we also make some process measurements with NOx and ammonia, NH3. Coal and lignite fired power plants make all those same measurements, but they generally add in SO2. Sulfur, of course, is the bad part of coal. Acid rain, you remember in the early 90s, the Canadians all complained that we were killing their forests and whatnot. Well, maybe that's true, but sulfur is good fuel. Sulfur burns well and helps us with generating a lot of heat so we can make a lot of megawatts. But there's also a lot of process measurements that we can make within the coal-fired plant there with same types of pollution control monitoring for SCRs, FGDs, flue gas desulfurization, and also for combustion control. And so oftentimes we're measuring O2 and CO in the boiler itself, or maybe at the economizer as a function for determining heat rate, and also so we can do a O2 CO trim. Let's see here. I included a couple of things that aren't necessarily power generation, but do fall into this that same line of equipment supply, and that has to do with cogeneration, both at the refineries and the petrochemical plants, but also I included wood-fired boilers at pulp and paper mills. They serve that same function and are required to monitor their exhaust emissions as part of that. Next slide, please. So you might ask the question, what drives our markets? And as a salesperson, you always want to know, well, where can I go? Where's the low hanging fruit? Where is the best opportunity for me to get a sale? Because I admire sales guys extremely, especially those ones that have to sell to eat every day. That is gut wrenching work. I admire Vector sales guys extremely. But there's a lot of different customers and a lot of different places that we could go to find our business. So one of the things that we want to look at is to try to hone in on where the best opportunities are. And so looking to see what drives our markets might be a way for us to hone in on those best opportunities at the time. And so what we do is we take a look at the regulatory requirements. Our general market drivers are regulatory requirements, something that the EPA's come up with, a new air quality permit requirement, in addition to the plant, something that might increase the pollution of the plant itself. Changes in reporting requirements. The EPA is real good about imposing new regulations, and they never back off. They always add more, ratchet down. That's their mentality. And so we can expect to see many more monitoring requirements as time goes on. The other market driver for us is the end of life replacement. So these systems have been generally in the power industry installed since 1990. So there's two parts of the Clean Air Act, and there was the phase 1 in 1990 and phase 2 in 1991. There was about 600 coal-fired power plants at that time, and the gas-fired business has certainly expanded since then. But there are enough systems installed currently now that we have a pretty good replacement cycle. Our replacement cycle is about an 8 to 10 year rotation. And so we take a look at customers that have had equipment in for about that length of time, and to target those ones that have severe applications that might cause their equipment to wear out more quickly, or that have technology reasons for updating the equipment. Like any other manufacturer, we have to go back to the drawing board about every 6 to 8 to 10 years because components are no longer available, or technologies changed, or computer chips have changed, and that like Microsoft, Bill Gates, we drive that industry through the development of new and better stuff. So about every 8 to 10 years, we have new and better stuff to offer, and that addresses the end of life replacement cycle. Sometimes we see that as component replacement. Sometimes we see that as full system replacement. And these systems can get up there pretty pricey, anywhere from $100,000 to $500,000, depending upon all the measurements that we have to make. Next slide, please. One of our real success stories here this last year, actually it's about 1.5 years ago, was Oklahoma Gas and Electric. I don't know if any of you all cover Oklahoma. Vector does not cover Oklahoma for thermal, but it's a good story anyway. A lot of old gas turbines at Oklahoma Gas and Electric, and some new ones. So there's an interesting blend. And the problem they were having was quick starts. And the EPA doesn't cut these guys much slack. So during startup mode, when we have instability, we have low stack temperatures, things like that. Very difficult to measure. And so thermal was put side by side. Next slide, please. Side by side with one of our competitors, and I won't say their name, but it was Teledyne. And next slide, please. And so we were put head to head with them and went through all the subsequent testing and so on and so forth. The thermal instrument was the clear winner, and was able to deal with certain startup and shutdown conditions that stumped the other guy's instrument. So the whole thing boils down to, and this is what the EPA really cares about, that relative accuracy number, and that's the comparison between the installed equipment and the stack tester, which is the independent third-party verifier. And they come out and they run side by side with our system, and we do a relative accuracy test. Well, that 3.9% relative accuracy is huge. Many times you're up 15, even 20%. In this case, the competitor was over the 20% limit because the converter inside their analyzer was not able to handle the high levels or the high ratios of NO to NO2. So we can talk some chemistry here if you like, but there are some nuances in gas turbines that make gas turbines different than coal-fired power plants in relation to some of the measurements. And so let's suffice to say that this was a real success story for us. And this is a story that we can tell our other gas turbine customers, especially customers that have a blend of both new and old turbines. And I think it's a great story to tell. Most of our customers have trouble with this relative accuracy, this testing. It's a mandated yearly testing. And so most of those end users are more than willing to hear what we have to say about that. Next slide, please. So you might ask yourself, when I go to the plants, who might I talk to, or who would be the person responsible for my equipment? And although there's a lot of names on here and a lot of positions and titles and whatnot, it really boils down to just a few folks that really have involvement in the equipment that we sell. And number one is the plant manager, the general manager, and oftentimes he is also the designated representative. So when you have a plant that emits something into the atmosphere, you have to, as part of your air permit, designate some person as the guy who goes to jail if things go sour, if you falsify data, if you don't submit reports, if the plant has a release and doesn't document it. And so this general manager, while we call him the designated representative, I call him the designated felon. And it does happen from time to time, but this is the person that has the most to lose within the compliance monitoring spectrum here. So I like to say I like to sell from the top down and the bottom up. And so this represents the top down and the bottom up. The other individuals that are involved in the environmental compliance monitoring are the environmental manager themselves, very closely tied with the designated representative, and often the person with the day-to-day responsibility for the reports or for EPA contacts. And oddly enough, is also the person most likely to take your phone call. So if you're a salesperson and you're trying to get a hold of somebody in the plant, if you will call the environmental manager, those are also generally the PR person. So if something bad goes wrong at the plant, you're watching the news in the evening, you see the guy, the plant representative, that's saying, well, that orange dust was, whatever, and it's not hazardous to people and whatnot. That same person will take your call because he doesn't always necessarily know who you are or what you're there to talk about. But I find that the environmental manager is my best entree into the plant. Environmental supervisors and SIMS technicians, though, can provide a good way in if you are a technical sort and go in through the instrument shop. That's the bottom up approach. The SIMS technicians are usually one of the INC guys, or maybe a specialty INC group that works within the plant that takes care of analytical responsibilities. Next slide, please. So when we're working with end users, and we often do, but sometimes we work through engineering companies. So the approach is a little bit different, but I've found over the years that the success with end users has been related to identifying the project early on in the cycle and identifying those decision makers that are involved with the selection of my equipment. And so there's a fair amount of legwork to do there, and I'm talking getting in early. We might even be talking a year early or a couple of years. Our intent is to try to get specified and to try to work with the end users to come up with a specific solution that maybe my competitors can't come up with. Demoing the equipment, let the customers get their hands on it, huge deal. You know, I bought a new pickup truck yesterday, and I went to the dealer, and he had a bunch of different ones there. He had some Fords and some Dodges, and he had this beautiful beautiful Chevy pickup. And he said, well, let's go take a drive. And I drove the Dodge and I liked it. And I drove the Ford and I didn't like it. And I drove the Chevy and I fell in love. And it was because they let me get my hands on it. Otherwise, I'd have probably bought the Ford to begin with because it had more horsepower and had a sexier color and all that kind of a thing. But once I got my hands on it, I liked the Chevy much better. It was more drivable and so on and so forth. Well, I find that same decision making goes on with our customers and allowing them to have a piece of equipment and put it on the bench and play with it for a while makes a big difference. Blair will confirm that. He and I did several virtual demos here in the last few weeks, and I think they've been very successful. We followed those up with delivery of a piece of equipment that they could actually get their hands on, and man, I think that'll seal the deal. So one thing, when you're in early on the project, you want to get budgetary quotes in the hands of the customers. We want to offer, and I don't know, that may have changed now with COVID, but in the old days, the ability to get on site, meet the people, walk the site, and take notes and pictures and drawings and whatnot was a big deal. It showed our involvement. It helped us to be part of the team. It helped us to present a solution. And so I don't know exactly how that's going to shake out, but being available to provide that kind of consulting, I think, is important. The other thing that we try to do is offer total turnkey. So while we're manufacturers, Vector is a systems integrator, has that potential capability. And so we try to offer turnkey, total turnkey as often as possible. That eliminates my competitors in a lot of cases that don't have that capability. We want to talk about things like what went wrong in the past, what went right, what are we faced with as far as application difficulties. We want to give them a lot of options. We want to talk to them as often as possible, and it's really all about developing that relationship. So that's the great thing about having a bunch of sales guys like Vector has, who are in front of the customer all the time and who can continue to carry that message. And then lastly, I would say, is to meet that schedule, because the schedule is everything. Some planner dude has laid this outage out for the last year and a half, and he doesn't want anything to screw that up. And the delivery of our equipment or the subsequent restart of the plant could be a real pain in his side. So we want to always ensure that we meet their schedule, whatever that might be, whether it's delivery or installation or startup or certification testing like we talked about before. Next slide, please. So we offer a number of things that we can help the sales guy. Often the sales guy might now, through the, because of the change in the way we go about business, the sales guy might be the only guy in front of the customer. I might be on the other end of the phone, or maybe not even present. So there's a few things that we can offer you as helpful aids when you're in a conversation with a customer or sitting across the table from them. And application data sheets are important, not only for documenting those things, the plant that you observe and the comments that the customer make, but it gives you great talking points. And so if you're sitting on the other end of the phone and you have our data application sheet and you can see the things that are important to us when we're quoting a system, you can sound like the smartest guy in the world, because you have all these lists of questions and you have the potential answers and you have great discussion points with the customer. And so I like the data application sheet. I can supply that to anyone after the presentation here. It's a good thing to read through before you get on a call with a customer. And then again, it helps carry that flow of a conversation and information that goes along with it. Product brochures, like anybody else, we have some great product brochures, but I got to warn you, they're all electronic now. Thermo doesn't have any hard copy data, hard copy cut sheets or product brochures. I'm not sure that's the best way to go, but that's the way our company has gone. We're completely green now. I always liked brochures because they gave you a place to make some notes. And if you were sitting across the table from a customer, you could slide that thing across the table and say, hey, take a look at this. And I like it better than the iPads that they bought for us, where I was expecting me and the customer going to crowd around that little screen and we were all going to look at that presentation. That's not permitted anymore. Social distancing doesn't allow you to see my iPad. And so I still like product brochures. I think we're probably going to print some out for the sales folks just so they have those and to be able to make a catalog. You know, in the old days, product brochures were contained in a big catalog, and you had space in the tech library. And it was, even if you had just one brochure, you had a 4-inch wide binder in order to take up as much space on the shelf and give your customer, give your product line some visibility. It's not about that anymore. Everything's on the server and it's all electronic. But I guess that's the way our business has evolved. Model code configurator, though, is an interesting electronic tool that helps us sort through the various options of all of the equipment that we offer and help the customer nail down exactly what it is that he wants us to quote. And that has to do with a lot of analytical configurations, depending on what we're going to measure. It has to do with the communication outputs that we're going to offer, converter types, so on and so forth. So the model code configurator helps you sit down with the customer and really nail down his solution. Sometimes it raises questions that wouldn't have come out any other way. And so one of the things that we like to do is, as you're having that conversation with the customer and these other questions arise, we have a lot of people, not only myself, but we have analytical experts, technical experts at our factory that are available to talk to our customer online. And so we find that the more people that our customer gets involved with, the more thermo people that they meet, the more vector people that they meet, the more likely we are to get the sale in the end. As far as other sales tools and support, price lists, of course, equipment demos, like we mentioned, virtual demos. And Blair probably is the best guy to speak to that, because we've done quite a few here just recently, but I think that they're a good way to go, and it's the wave of the future. And quite honestly, it allows me to do a bunch of those every day and customers than when I was traveling, which, you know, if you make 3 or 4 calls in a day when you're in front of a customer, that's a pretty good day. But in the virtual world, I can see 10 or 15, or, you know, the sky's the limit, is only limited by how willing I am to wake up in the morning. RS, that's me, that's our regional sales manager. I don't know if I mentioned this before, but I manage the Rocky Mountains and the Midwest territories. Our technical support folks back at the factory that are always available to assist us. Quotations, and then our customer service department, which are those folks that generate the quotations for us. Next slide. Does somebody have a question? I thought I heard someone maybe speak there.
Just clearing the throat.
Okay. Hey, sales is a team sport. Remember, it takes us all. And if you feel like you have to be the technical expert, you're actually doing us all a big disservice. It's great to be the expert, but what happens is, if you can answer all the questions, you don't have a need to drag the rest of us in with you. And so I have to admit, I might have been guilty in the past of saying I didn't know the answer to something, only to be able to have a secondary meeting or a secondary connection with that customer and maybe introduce them to an engineer or somebody at the company. And so don't ever feel like you have to do it all yourself, and don't feel like you have to be the technical expert. Be the professional sales guy, and then try to drag us in as needed. We find that we have a better success that way. Next slide. And next slide might be the last slide. So I don't know how we decide to handle questions, but if anybody has any questions, they can use the chat, or they can ask those questions now. I think I got a few extra minutes left. I was even quicker than Boyd there.
Jeff, looks like Brian Sullivan's walking up, so he's probably going to chime in for a second.
No, I just wanted to go back and touch on the systems perspective, right? You put a success story up there about Oklahoma Gas and Electric, and said that we don't have Oklahoma. I just want to make sure that it's clear that we have the capability to sell complete systems throughout the entire Vector territory, and we have support from people like Jeff inside of Thermo. So if you are outside of Texas, by all means, do not hesitate to get involved in discussions around SIMS upgrades and replacements of systems and things of that nature. And that's everything from just the standard old CO2 NOx system all the way through to mercury. So anywhere we have a foot, we have a partner in Thermo that we can work with, and we have support there. So don't step back from that.
I didn't mean that Oklahoma comment. I plan to fix that problem soon, Brian. You
Well,
know that.
I'm giving you time to fix that. In the meantime, we'll sell systems.
So that is a good point. That integration capability kind of allows us to go where we need to go, and that may be outside the territory. Maybe we partner with others in other regions, but that's huge for us right there. The systems are the vehicle for our analyzers. And so to be able to offer that complete turnkey capability, I think is a big deal. Having local integration right there in Houston. Oh my gosh, how many customers in that area want to come over on Thursday afternoon and see how things are going? They want a local integrator that they have a relationship with. And so having that ability right there, I think is a big deal. But it does, like you said, extend beyond the borders of your territory. And I think it kind of opens up the rest of the world to us.
Okay, Jeff.
Jeff, can you hear us from back here in the back of the room?
I can hear you.
Okay, Nikki's got a question from somebody online.
Okay, so Paul is wondering which power plants are currently using something from Thermo?
All the plants. San Miguel Power, XL Energy. Help me out here, boys. Vistra.
Yeah, so Vistra, which is Luminant, American Electric Power, NRG, LCRA, San Miguel,
LCRA.
City Public Service.
But can we provide our guys?
Yeah, we can provide a list. I would say that it's more likely than not that a power plant, whether it be coal-fired or gas, is going to have a piece of thermo equipment or be knowledgeable about thermo equipment. So yeah, the vast majority of them have thermo equipment. That's a fair statement, isn't it, Jeff?
Oh, I'd say probably all of them. I was trying to think of some that didn't. Austin Energy does. City of San Antonio. You know, maybe I'll just make a mention here. One of the interesting things about thermo is that the analyzers that are used to monitor the emissions going out the smokestack of your power plant are exactly the same analyzers that TCEQ and other local air quality agencies are using to measure the outside air around those plants. And so one of the selling points might be for the plant is be sure you use the instrument that the state's using in order to second check you.
Any other questions real quick for Jeff? We'll have more time for questions at the end, but Brian, anything else you want to add right now?
No, sir.
All right. Thank you, Jeff. Another great presentation.
Hey,
Sure. Yep.
You see how my picture's looking better? The sun's finally coming up here.
There you go. All right. So
Thank you.
we're a scooch ahead of schedule. Nikki, were you going to say something?
I was just going to remind everyone that's online, I can tell when you're not looking at the presentation and you're doing something else. So if you're online, please make sure you're watching the presentation. There's quite a few of you that are doing something else.
Please, no multitasking. These guys spend a lot of time and energy helping put these presentations together for them. Let's give them our attention. We are 5 minutes ahead of schedule. We'll stick to the schedule. And by that, I mean, you're going to get a 15-minute break instead of only 10 minutes. Now you can take the time to make the phone calls and the emails. We'll give you the extra 5 minutes for that stuff. But let's please be back and ready to go for 8:45. Thank you again, Jeff.
All the salespeople.
Oh, yeah. Thanks, everyone. Ooh, doggy.
I have to give these to Patricia. It's our safety form, so it's required.
Dave, are you with us or did you walk away? Dave has paused, so he must have walked away.
Can you hear me now? Hello?
Hey, Dan, are you on?
Now I am.
Okay.
All right. Sorry, Dave. Yes, we can hear you.
Okay, yeah, I see my green is there now. Okay, because I clicked on mute. Yep, I'm here.
Oh, good.
So Dave and Dan, are y'all just gonna tag team or does Dave want to run with it or?
I mean, I can, Dan, if you want me to do it and you just want to stop and chime in on any of the, well, that's what we normally do when we present. I have no problem if Dan needs to step in and add anything that I may forget, so.
Yep.
Unless
No,
you
why-
want to do the first couple slides.
Yeah, however
Now I
y'all
can-
want to do it. Dave, I'm
Yeah,
assuming you still can't advance slides right now. You're gonna need me to advance slides for you, I think.
Well, I'd like to. I have quite a few slides that build, and I will be telling someone to click quite a bit. I was asking Nikki, just her and I earlier during the break, we could do a test run and see if I could advance them. If you could put it up.
I am going to give you keyboard and mouse control right now.
Okay.
And I'm gonna say, okay. So you have keyboard and mouse control over my machine now, I think.
Okay.
You're advancing on my end.
Yep.
Yep. You know what
That's
it
it.
was? My screen resolution was messed up before, and I couldn't see the little the arrows at the bottom and everything. Okay, good.
And I think that's what was happening with the other presenters too. They didn't see that.
Yep. So I'm going to leave my screen exactly the way it is, not touch anything.
Well, that's it. I am not going to touch my laptop ever again either. So. Oh, here
Yeah, I
comes
see all the normal PowerPoint presentation controls across the bottom, so I think we're good.
One thing I can't do is I can't mute and unmute from here, so you might need to mute and unmute if we need to.
Right, I'll do that now.
Okay.
Okay, that sounds great. I'm glad that you can advance then.
Yep. So we'll be back at 6. Oh well,
Okay.
I don't. For me,
Yep.
6:45, but in 10 minutes.
Yes.
Yeah, you got 10 more minutes.
Okay.
Okay.
Thank you, guys.
Thank you.
Thanks.
Yep.
Dave and Dan, we're trying to herd all the cats back into the room right now, so we ought to be good to go in just 90 seconds or so.
No worries.
Can you
But
still
bunch
hear
of
me?
sales guys, you give them a break
Yes.
and man, they just scatter like cats, right?
Yep.
All right, we're only missing one or two, and they ought to be popping back in any second. And Dave, we'll go ahead and turn it over. Dave, are you going or is Dan?
Dave will run it.
Okay,
And
cool.
I'll run it.
If I need to add anything, I'll jump in, but I think Dave's got it covered.
Well, Dan, and that's
Maybe
the other
Dan-
reason I wanted you involved too, is this is the initial unofficial announcement of the partnership. Because remember, we said we were going to announce internally both organizations on Monday. We've got to go ahead and address this here because this is set before Monday.
Yep.
Okay.
You want to
Understand.
do that then, Dan?
Yeah.
Yeah,
So
I'll say I'll kind of start that off, and then Dan Marquis, you jump in anywhere you feel appropriate. And
okay.
And I didn't get a chance to introduce myself earlier, so I'll do that real quick at the beginning here on the second slide.
absolutely perfect. Thank you. Sorry about that earlier.
No, that's okay.
By the time this thing is over with, we're gonna have it figured out pretty good.
Right. We didn't even have to get any 10-year-olds for IT support.
Yeah, that's what we need is one of my 12-year-old or something.
Someone's nephew.
Keep up and going. All right.
No, I think it's actually worked pretty well with everyone being where they are.
Vince is here. Larry's not here. We're not waiting on Larry or Blair. I think we got everybody. All right. So guys, if we can, let's go ahead and get started here again. Guys online, I'm sorry my camera's off, but I'm up here in a dark corner of the conference room is why we got it switched off. But anyway, we're going to move to our third final vendor presentation this afternoon, our partner presentation this morning. A lot of you have heard rumors around the office or little bits and pieces, or on the power call yesterday, we talked about there's going to be an announcement of a major valve partner joining up with us. The official announcement, you kind of heard me talking about this with these guys just now, is going to go out next Monday. So we are asking, a bunch of sales guys to keep a secret. I know that's probably next to impossible, but try to keep the chatter on this down until next Monday. You'll see an official announcement go out from Nikki internally, kind of letting everybody on our team know. And what we're having to do really is give IMI enough time to be able to notify their team. They're changing their market or how they're going to market from being factory direct to coming over and using what they call an agent, we call a rep. And so there's a lot of moving parts to this. So we do ask that you kind of keep the chatter on this low till Monday. Anyways, this is the big secret we've been talking about. This is the huge announcement we've been talking about. This is an incredible partnership for Vector moving forward. We've been really looking for that anchor to tie down our valve portfolio. And the IMI opportunity came up a few months ago. Dan Marquis and I have been going back and forth on this. I know it's confusing because you're going to hear Dan a lot. You ought to imagine how our calls go with each other. But we're super excited about this from the leadership team. We're all involved. There are a lot of good things coming. We're going to take a look at some of their offerings in the power market. Because they are super strong in the power market. And I think it's going to tie in well. Larry and I were talking about this a while ago with a lot of the things Anderson Hauser's doing with the instrumentation and the control side. A lot of those signals are going to be going back to IMI valves to control boiler feeds and to control the water injection going into the steam and things like that. So the synergies here are great. Really exciting. There'll be a bigger launch on this later. Dan, is there anything from your side you want to get out there right now?
Yeah, just a couple quick comments here. Again, we're looking forward to this. This is not a big secret within our organization that we are kind of moving in this direction. So a lot of the folks know about it, but there's still some moving parts to this in order to properly, get this right. So, we are taking those steps now. And it's, again, it's not a big secret in the organization that we are moving this in this direction. We're not doing it all at one time. We are maintaining a few house accounts, which again, we'll go into more detail a little later on. So this presentation here is just really meant to provide you with a high level overview of what it is that we do and where we play within the power market. But we also get into the industrial side, the CHPs, the petrochem side, the refineries, LNG facilities. So there's a lot broader product portfolio that we'll be getting into later on. A large portion of our business and focus is going to be the aftermarket side, is maintaining a lot of our current customers and supporting our current customers that have, CCI equipment as it is now. So we were looking forward to the partnership here. I think there's a lot of exciting opportunities. And so, you'll definitely hear more a little bit, later on. So just bear with us. And at this point, I guess I can turn this over to Dave.
All right. Thanks, Dan. Can everybody hear me okay?
Yes, sir.
All right, cool. So I had some audio problems earlier. I couldn't introduce myself. So just real quick, you see three names here. Dan introduced himself. My boss, Ori, wasn't able to be here. He's got a 1-month-old baby boy and a 2.5-year-old daughter, so he's having a lot of fun right now. Myself, I came from a design engineering background. I've been at CCI for 14 years, almost 15. Before that, I started out as a design engineer working at Parker Aerospace, doing control valve design for aeroderivative and also airframe engines. Since I've been at CCI, I've been a design engineer, the design engineering manager for our fossil power group located in California, doing at the time about $25, $26 million worth a year of design, things that Dan was selling at the time. And now for the last several years, I've been an applications engineer. Applications engineers at CCI are a little different. We report up through engineering, and we're still very technical. We kind of liaison between the sales side and also back to the factory and also the design engineers. So I do a lot of customer training, but I also spend a lot of time at site troubleshooting valves, doing training at plants, and things like that. So it's a good role because I get to cross back and forth from the sales side back and keep my old technical skills intact. So with that, I'm going to go ahead and move on. Real quick, we only got a couple slides on this, but since this is a new partnership, if you see here, my shirt still says IMI CCI. I started out in the CCI world, which I'll get to in a slide or two, but IMI as a whole is basically 3 divisions. And where we come from is the IMI critical division of the 3. There's critical, precision, and hydronic. And just to break it down a little bit further, underneath that master brand and then our divisional brand, critical engineering, we work, as Dan said, in many industries, and we have a lot of brands underneath IMI critical. So like I said, I come from the CCI background, but we have all of these other brands that we have purchased over the years. And so you'll see a lot of different IMI something afterwards that represent many of the products that we'll be out trying to work with you guys on. Any comments, Dan? Good. Okay.
Nope.
So
you got it.
I'll skip this one because we've already mentioned it. We work in pretty much every industry, and I'm just going to jump right into it because what I want to do is talk a little bit at the beginning about CCI's philosophy for designing control valves. So there's going to be a little bit of fundamentals here on how we look at how a good valve design works. So it's going to be a little bit different than what Boyd and Jeff did, but I got to point out some things they said that were great. Every customer and every plant they mentioned, I was like, check, 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 check. We've got product in those. OG&E, tons of their plants. All of the EPCs that were shown, we've worked with all of them. So it's pretty interesting. And then also what Boyd even said about the state of the industry and the way combined cycles have transitioned over the years. I was shaking my head if anybody could see me. Yes, yes, yes. Everything they were saying completely aligns with what we're seeing happening. And it's very relative to control valves. So with that, let me kind of get into it a little bit. And what I'm going to do is explain to you, again, CCI's design philosophy. I was told, and I hope I'm not offending anybody, but I was told that maybe we don't have a strong control valve background in this audience. Is that true, false, maybe?
It varies by salesperson. Some of the guys probably have 10, 15 years of more, but some of the guys probably have less than 1 year. So it's widely varying.
Okay.
So go ahead and start at the ground
Okay.
floor and build up.
Okay, so some people will probably be able to present what I'm presenting, and then, okay, for everyone else, maybe a little bit newer. But so I'm going to start off here with something. I'm glad Jeff led me right into this because he was talking about buying trucks. But if you were going to buy a truck and you needed a truck for a certain purpose, you can look at two things: the performance and the severity. Performance might be how much torque or horsepower. The horsepower it has, but it also has a severity component, meaning that it might have some torque, but can it also, pull a certain load, something like that. So you can see what I call the truck hierarchy. Things get a little bit more expensive and a little bit complicated the higher you go. But there's also the idea of, did you buy the right truck for the right service? So if you try to load up a half-ton pickup with too much weight, something like this might happen. But you can destroy the multi-million-dollar truck just as easy if it's not chosen for the right duty. Why am I talking about trucks? Valves are very much the same way. In the valve world, there's a hierarchy of valves. Everyone's seen butterflies, balls, what we start calling general service, and maybe not so much for you guys, what we call severe service duty. Same thing. You have performance versus severity. Performance could be the pressure drop it has to control at a certain stroke speed, or there's some particulates in the gas stream that are going to affect the way the valve in trim has to be designed. So as you go further and further up this hierarchy, you have higher and higher technology. At IMI Critical Engineering, again, I mentioned earlier, it was very small in the slide. We have different brands that supply different levels of these performance of valves. IMI Orton, IMI TrueFlow, and then again, more of my background and maybe some of Dan's is the IMI CCI. I apologize, I'm going fast. These slides are a little bit more introductory. Then within CCI, stepping down even more, we've got what we consider general service valves and severe service valves. So what you can consider a general service valve might be a lower pressure water control valve, something that's operating around 300, 500 PSI, even 1,000. For us, that's maybe general service. A severe service valve, you could think of something that's controlling high mass flows with very high delta P's. Jeff was talking about coal plants earlier. Just yesterday, we were looking at retrofitting a customer's valve at an ultra supercritical coal plant in Turkey that has a pressure drop of 6,000 PSI. So that's a very large pressure drop to try to control, a process accurately. So with that said, one of the things that we spend a lot of time looking at is the trim, the valve trim inside the valve that controls the process, either the water or the gas or steam that you're controlling. And we're going to get into this more in future presentations. This is very high level, but there's many different types of control elements. Over here on the left, you can see, I'm not going to do that. I'm just going to use my pointer. There's an open ported cage, so fluid can flow through this open port and out the valve. Over here, we have what's called a single stage multipath. So there's one stage of pressure let down, but it goes through many, many paths. And slightly more advanced is multi-stage multipath, where you have many flow paths going through different stages of pressure reduction. CCI has these types of offerings, but now I want to explain to you why, if you don't have enough stages to let down pressure in a valve, what can happen. So the first one I'm going to show, if you've never seen a severely cavitated valve, this is a great set of pictures of cavitation inside a control valve. Over here on the right, this was a two-stage valve that did not have enough velocity and pressure control within the valve element, so that when the water was coming through the valve and exiting through these holes on the inside, the fluid was cavitating and ripping apart the inside of the control element. I'm not going to go into cavitation in detail, that's for another time, but here's a number to consider. When a cavitating fluid, when it's a supersonic collapse of a bubble, it imparts stresses on the metal of 200,000 psi, 200,000. We don't have a metal that can handle that stress. So if you hear people talk about cavitation control or something like that, it's a little bit of a misnomer. You're not going to control cavitation. What you have to do is eliminate it. You have to get rid of it. Erosion. This is wet steam erosion here on the right-hand side. Look at this one here. It kind of looks like a rat or some kind of varmint kind of chewed up and just ate the metal away. So these are very destructive forces. So these are typical severe service failure mechanisms that we see in both the water and steam side. Go through that one quickly. This is a very large hot reheat turbine bypass valve. This is a classic example of vibration, but again, caused by not controlling the fluid inside the valve well, and it caused major problems with the actuator that was over here mounted off to the right side that's now just decoupled from the valve, such that the valve was stuck and couldn't move. So vibration is another large failure mechanism that we will all be dealing with. So the key to all these things, cavitation, vibration, noise, I didn't mention flashing, but we'll throw that in there. It's all due to fluid velocity. I mentioned pressure drop a little bit earlier, but I'm going to walk you through a little story now about why velocity is a little bit more important than pressure drop. Okay. So there's some math behind these damaging mechanisms. I'll talk about cavitation and erosion here. If you look at the equations for what cavitation is, it's actually the amount of material removed in a unit of time to the 5th and 6th power of velocity. So you can imagine that that amount of material removed can get very large very quick as velocity increases from low velocity to high velocity, because it's a function, it's a power function. And erosion is the same thing. Steam and water are very erosive. In the higher velocity, the worse things can get. Okay? So what CCI does is we look at controlling the velocity. We're going to take the pressure drop. We know what that has to be, a P in, P out of the valve. But then we're going to look at the velocity that that pressure drop imparts, and that's really what we want to control. So we like the waterfall analogy. This is the, I think this is the Canadian side of Niagara Falls. So if you think about what's happening here, you have a lot of potential energy at the top of the fall, and you're going to have a lot of kinetic energy at the bottom of the fall. And if you just let this fluid fall over this fall in one drop, you're going to have a lot of erosion. You know, there's a big pool at the bottom of the waterfall. Well, if you take that same pressure drop, the same P1 and same P2, but you control the kinetic energy going down that same elevation. This is like an example of a fish ladder out in the western United States. You have much less erosive effect at the bottom. So the point here is same P1 and same P2, but I've controlled the velocity. This is the key design philosophy between a CCI drag valve and controlling the velocity and the energy inside the valve. And just to kind of put another nice little spin on it, I'm going to try to stop this at the right moment. So, oh, that was fast, I'm sorry, but if you look at this waterfall as it's flowing, this is very clear. This is the same waterfall, P1 to P2, P1 to P2. Look at what's happening over here on the left-hand side. You can clearly see that there's a lot more energy. So imagine that's your valve trim. So if I have a globe valve, I have a ball valve that's controlling P1 and P2, but not the velocity, and I have a CCI drag valve controlling the same one, P1 and P2, I'm going to be able to mitigate the negative effects of things like erosion and vibration and things like that.
Dave, is that IMI's little waterfall, or you just found that somewhere? Everybody in the room is like, man, that is a great example.
So a guy that Dan and I know, one of our salesman and program manager for CCI, Walter O'Farrell, he's from, oh my gosh, I'm going to forget, Honduras or Guatemala. I don't know if you remember, Dan. He took this at a hotel down in Central America and sent it to me and said, I've got the perfect drag slide for you.
Okay, so yeah, y'all found that somewhere. You didn't create that. Okay.
We did not create it. He actually just happened to be in a hotel lobby on a trip one time and found it.
Good deal.
Yeah. But I think it illustrates the point pretty well. So what's a good velocity? You know, I've said, you know, velocity needs to be controlled. Well, let's look at some relative numbers here. Drinking fountain, 3 feet per second. A fire hose might be 70 feet per second. You know, that'll rip the skin off your arms. Hopefully not, or peel the paint off your car. Sorry, the slides have a mind of their own. Well, in a control valve, if any of you guys are familiar with ISA standards, for good control of a non-cavitating fluid, we want to keep the fluid in the trim inside the valve less than 100 feet per second. If you've got cavitating or flashing fluid, we like to slow that down a little bit. Again, in further training, we'll get into that more, but there's different levels of velocity control, but the general guideline is you want to stay below about 100 feet per second, which is pretty high. When you look at gas or steam service, because gas is a compressible fluid and has changes in density as there are changes in area, when you go through different flow paths in this valve, there's going to be density changes, which also density you have to think of as velocity. So we're controlling velocity. So in a gas, we have to think of density. So it's a little easier to think of controlling the dynamic pressure or the kinetic energy. There's many different ways to call it, but we're looking at a different type of target. It's not velocity, but it's a dynamic pressure that has a component of velocity. Same fundamental theory, though. You have to control, limit it to some number that we've all agreed on. Okay. Another important point too about our steam valves and gas service valves. Dynamic pressure, it has a component of noise, and we're always worried about noise and on the steam and gas side. I'm going to talk about that a little bit with our applications here real quick, but you know that you're going to have with the steam valve some noise requirement. It might be, OSHA requirements of less than 85 dBA, but just yesterday we got a requirement for a trash burner in Massachusetts. Yes, they now want new noise requirements out of the silencer, of less than 70 dBA. That's really hard to do. So the point I'm trying to make is that the requirement they gave us of everything else that system has to do is the noise coming out of that system for our valve and our silencer has to be less than 70 dBA. And that all boils back down to controlling this dynamic pressure of that steam flow. So I already mentioned this, but the velocity created in the valve is a function of the pressure drop. You've got high potential energy on the inlet and higher kinetic energy on the outlet. So as that energy is transformed into potential to kinetic energy, you have an increase in velocity. Okay, so similar to that waterfall I showed, one of the IMI CCI designs in our drag valve is to send the fluid through a tortuous path, right angle turns. And by doing this, again, P1 here, P2 here, P1 here, P2 here, same pressure drop, but I'm slowing that fluid down. I'm controlling the energy as it's going through. where in a single stage drilled hole cage on this side, I am not doing that. So yeah, the valve can still say handle the pressure drop, but most likely it won't handle the velocity if it's a single stage control to the level that it needs to be controlled. Okay. So CCI drag, it's been around for 50 years. We have other similar technologies, but drag is what you'll hear a lot when we talk about severe service. And basically, you take that tortuous path, you put in a certain number of turns. There's different manufacturing methods to stack these turns together. In this instance, it's a brazed disc. That becomes your control element in the valve. And as the plug moves up and down in the valve, it opens up these tortuous path channels to fluid flow to control the energy and the velocity in that fluid as it exits the valve. This is showing flowing under the plug, but the same theory applies if you're flowing over the plug, and for gas and steam and for water. So this is just a little break before I go on the application, but based on everything I've said, anybody know how you could beat Usain Bolt in a 100-meter race?
Shoot him in the leg.
Make him run a bunch of 90-degree turns. So it's just a little, you know, if you can slow him down by making him turn, then he's not going to be there. So yeah, just a bunch of silly analogies to kind of express the fact that every time you take a 90-degree turn in fluid flow, you take a certain amount of energy out of the flow, and that's how you're controlling that energy. So that was my intro to drag technology, which was about a third shorter than what I normally do. Before I go to our applications, are there any questions?
No, great representations of why it works and brought it down to our level for sure. Thank you.
Okay. And I assume in the future, as Dan and we set up more in-depth trainings, you're going to hear me talk, or maybe my boss or somebody, a lot more about, you know, the control of water and control of steam. Like I said, it's basically the same theory, but we will talk about the challenges and then things that we need to do. And looking back at what Jeff and Boyd had, we don't have that today since this was introductory. It's the same idea though of knowing what questions to ask, because the questions you have to ask your customers, if it's a water service valve versus a steam valve, those are going to become very important. But that'll be in later training where we get more in detail on the applications. So
yeah, if I might add, Dave, if I might add just 1 second. And the whole reason we've kind of gone through this velocity control methodology is this is what the company was founded on. So when you hear a lot about CCI, a lot of people think about drag technology, you know, tortuous path. That is what the company was founded on. So that's why it was want to kind of cover that, so you get an understanding of a lot of the way that we approach valve applications, be it steam, be it water, be it gases. You know, we utilize that same principle throughout, you know, which is velocity control.
Yeah.
So.
Dave, you have a couple of quick questions real quick, I think, before you move on. Craig, you were saying.
Yeah, so you mentioned water and steam. Do you guys do process valves as well for chemicals not related to both those things we're talking about?
Dan, could you hear that? I couldn't quite hear the question.
Yeah, he's just asking about doing processes other than water and steam.
Like a different fluid, or could you give an example?
Yeah, so we'll control any liquid or gas, correct?
Yes, but and Dan, maybe I'm going to defer to you, but we do have, and I know that slide was small and quick. We have other brands that work in other industries outside of power. So if you're I don't know if you're speaking outside of power, or if you're trying to stay in power and talking about some like glycol or something like that.
I know Dan, you can talk about it. We'll be looking at their entire offering. What we're covering today is in the power and energy.
Right.
But yeah, they have an offering
off the chart.
Yeah, so we can control slurries and that sort of thing. It's just, you know, different brands within the organization.
Yeah, I'm guessing Dan, you'll be bringing in all the other AEs and
Yeah,
experts
Nikki
from
had a
those.
couple.
Yes, sir.
Nikki, is there a way for me to see those questions, or you just have to relay them? Or
Okay, we had a couple questions from those online. So first off, loved the waterfall examples. It was awesome. Just a comment there. Next question was, how do you prevent leaks between the discs?
were you guys able to hear that?
Yeah.
Oh, yeah. Yeah. Let me go back because I don't have enough time to talk about, well, I'll mention it at the end, but we're also doing additive manufacturing nowadays, or 3D printing. But these disc stacks, our historic manufacturing method is these are EDM, electrode discharge machines. So these discs are sitting in an oil bath, and the laser comes down and burns these pads. Once those discs are manufactured, and these could be 16-inch, 8-inch, various sizes of different materials, they get put in a fixture with a brazing material between them. That then gets heated in the oven and it becomes a unitized stack. It's actually a single solid stack that started out as anywhere from 10 to 50 individual, what we call discs. But that's just one method. We also do, like I said, we've got more additive manufacturing going on nowadays. Matter of fact, pretty much all of our spray water valves, our high pressure spray water valves up to about a 2-inch trim diameter, 2-inch diameter, those are all additive manufacturing or 3D printed stacks. We're heading that way, and we're expanding that range to bigger and bigger disc stacks constantly.
Nikki, is that?
Okay, then there was one more question. Is the overall size of the drag style valve comparable to more traditional, example, the Fisher control valve, given the same pressure drop?
That's a great question, but it would lead me to my very last slide, and that's so I'm part of a new business unit at CCI called Retrofit 3D. You're going to hear a lot more about that. So Retrofit 3D is specifically designed to retrofit competitors' valves, knowing that our traditional drag stacks maybe had to be a little bit bigger, but we've overcome that situation, because with additive manufacturing, the flow paths that we can come up with are pretty much unlimited. Because the manufacturing method is just more robust, meaning that the flow passages can be very intricate, where you couldn't do that with a subtractive manufacturing like this. So what we have is we are able to go in with the same size nominal valve. Let's say it's a 4-inch nominal valve, and Fisher's control element had an OD of 6 inches, where in the past, TCIs would have had to have been 8 inches to get that same control. Well, now we can package it all in the same size that the Fisher valve is, or not. And I keep saying them, I'll just say other competitors' valves. So yes, historically that was true. We would have needed a slightly bigger valve.
Okay, and we're going to do more product training in the next couple of weeks, guys. So
yeah. And when we say bigger valve, a lot of times it's the gallery area that we're referring to, not so much the inlet and outlet connections, right?
Yeah. And I would even say, you know, if you guys are familiar with B1610, it's a standard that says a globe valve should be this size. But even the big Fisher, Mason, Nealon, everybody who does severe service valves that we compete with the bigger, higher end valves, none of their bodies typically, you know, their galleries are bigger too. But yeah, when you get to the smaller valves, we could be a little bit bigger in the gallery, as Dan's saying. But like I said, we have a program that we're working on to help be able to replace some competitors' trims and meet and fit inside the valve.
Awesome, thank you.
Okay. So this is my super cartoonish power plant here. I've got a couple nicer slides, but for those of you who haven't worked in a power plant or been to a power plant, I like showing this because it doesn't matter if it's coal or natural gas. But the point is, you're burning something to make steam, to spin a turbine, to spin a generator, to make electricity. If this was a combined cycle plant, you might have the gas turbine on the front here making electricity coming out the front. I'll show that in a second. So I'm showing this because today, the focus for us today was power applications, and I'm gonna have to give a very high level review of just some of these applications to build the base for future trainings. So how much time do I have, by the way?
8:50 Central Time.
Oh, okay. We're in good shape then. Okay, so
9:50. I'm sorry. You got 30 more minutes.
okay,
But don't
good. Yeah, I don't think I'll have to rush too much and leave time for questions. So for us in our group, IMI CCI, IMI Critical Engineering.
I'm sorry. They're telling me you got 15 minutes.
Oh, 15. Okay, I think we'll still be fine. We excel in high temperature, high pressure steam and water applications. We've mentioned this already, but combined cycle, supercrits, combined heat and power, everything. So the point is, and when I say high temperature, high pressure, that's relative. It doesn't mean we don't do what someone might say, well, that's low pressure. What it means is we're not the real general service valves, you know, where you see hundreds or maybe thousands of them in the plant. And within a combined, and I'm going to talk about combined cycles here, and I'm just going to skip this slide and go to this one. It's a little busy, but you guys will have a copy. This represents a very modern combined cycle plant. It's called a triple pressure with reheat combined cycle. And we're not going to look at everything on here, but what I want to point out, and hopefully you can see the difference, is there's a bunch of red and there's a bunch of blue, representing steam services and water services. Now, in a combined cycle plant, you've got a gas turbine that's got fuel injection and it's creating electricity. But you don't want to waste the exhaust heat. So you take that exhaust heat and you send it through all these heat exchangers and you make steam in these drums. And you take the saturated steam and you superheat it and you send it out to your turbine to spin the turbine to make more electricity. That's a very quick description of a triple pressure reheat combined cycle plant. CCI has valves in almost all of the steam and water control points in this plant. Main ones are feed water control and pump recirc control, and also the attemperator systems and the turbine bypass systems ahead of the steam. Turbine bypass systems are some of the more complex, and I'm going to mention those in a second. But I'll just move to that now. I won't talk about this, but I wanted to show you this slide just to show you that the main point is you've got steam side, you've got water side, you have two cycles, you have a Brayton cycle and a Rankine cycle, and you combine those together to get the maximum efficiency out of the plant that you have, and we supply valves for all of those control systems. Just to give it some scale, this is one of the biggest plants you'll see like this, the mid-cogen, if anybody knows this one. There's actually 12 Hercigs. Same thing, you've got a gas turbine generating, making steam in a Hercig, sending steam to the turbine to make more electricity, but it does an extra step. It actually takes steam out of the turbine and out of the Hercig and sends it for process across the street to a Dow chemical plant. So it not only provides electricity to customers and businesses, it also supplies steam at the same time. So in a situation like this, CCI would still be involved in designing control valves for this side of the process, as well as controlling steam being let down, going across the street to the customer, or say process applications.
Dave, where's that at?
Just to clarify, Hercig is a heat recovery steam generator. It's just, we use a lot of, acronyms. And
it's funny you said that, because Boyd was using the acronyms and I was laughing too, because I'm like, I don't know what these are. Sorry. So the heat recovery steam generator is this section here. And heat recovery meaning it's taking the heat from the exhaust from the combustion turbine or the gas turbine. It's recovering it and using it in, I'll just call it a big heat exchanger. It's not technically that, and it's making steam. So it's the steam generator and sending that steam up to the turbine. So heat recovery, steam generator.
That Dow example though, where in the country or where in the world is that at?
Everywhere.
Okay, so that's all right. I just didn't know if
But
it.
Dow, he's referring to the Dow. Did you say Dow example?
Oh, Dow.
Yeah.
Sorry, that's
yeah,
here in the U.S. Yeah, Mid-Cogen. That's actually here in the United States.
Okay.
Texas, isn't it?
Yeah, Texas. I'm sorry, right here, Consumers Energy. You're right. So I kind of wanted to show you one of the biggest examples because, we also have, 150 megawatt plants we supply to too. But I like this one because it also shows the fact that you've got process coming out. And it's just a really nice graphic because it's not as busy as mine. Okay. So real quick on turbine bypass, we've been doing this a long time. Dan mentioned drag. CCI was started in 1961, but we've got divisions that have been doing steam conditioning in the pulp and paper industry since 1923. Dan's got a long history with that particular division. BTG, which you'll hear.
Clear.
Yeah, he doesn't have that long of a history. But we've taken the steam conditioning expertise that we've had since the early 20s. Now, in the last 20, 25 years, we've done a lot of turbine bypass. So this is a little bit old slide. It's only updated to 2016. But since 2016, commissioned plants, new construction, we've won 33. I'll say everybody else has won 9. So we have a huge market when it comes to the new construction wins. Real quick, what's turbine bypass? Again, one slide. It's basically steam that bypasses the HRSG or bypasses the turbine. So just real quick, I'm going to mention this. When you fire up a gas turbine, it runs quick and hot. If the plant has been shut down, as one example, this steam turbine can't take that hot temperature. It takes time to ramp everything up. Think about a steam turbine. It has very, very thick casing on it and very, very thin titanium blades. If you were to just dump super hot steam into that turbine too quickly, it's going to cause major problems. So one of the things you do during a plant startup is instead of sending the steam out of the boiler or the HRSG into the turbine, you bypass it back into the system. It goes through what's called reheat. It goes back to the system and may even go back to another bypass into what's called the bypass to condenser. This is just one setup. There's several different varieties. But the point is, the reason it's called bypass is you're bypassing the turbine for a couple different reasons. It might be during the startup, like I had mentioned, or it might be that there's a plant trip and they can't send steam to the HRSG because it's shut down and they have to dump all the steam somewhere else. Not easy to do. These are large valves. I'm going to use the hot reheat as an example. This could be an 18-inch diameter plug that weighs 500 to 600 pounds. It has to open in 2 seconds with basically no deadband or hysteresis and stop. And it can't bind, obviously. So you're putting together 5 or 6 different materials in a valve body that has to take a lot of thermal shock. The other thing you're doing at the same time, and I'm just going to show the next slide while I talk about it, is you're injecting water into that valve at the same time. So on a hot reheat system, you might have 1,000-degree steam sitting up here. Valve gets told to open in less than 2 seconds, and now I'm going to inject 300-degree F water into this. So what could go wrong, right? So a lot of thermal management. You can see how big one of these valves is here. This is our shop in California with one of our senior techs, Jimmy Kent, standing next to it. That's the valve without the actuator on it. The actuator is another 6 feet tall. So it's a very large piece of equipment that has to have very fine accuracy and control. So thermal management is a big deal. High pressure drop. you've got,
How much?
2,000 PSI steam. I mentioned earlier about in gas and steam service about noise and vibration. When you expand a gas, the pressure drops, the velocity increases, there's changes in density, it creates noise. So at every point in this flow path of a turbine bypass system, we have to analyze the noise that's being generated and make sure that we're meeting the noise requirements at whatever point we've all agreed to downstream. And I just mentioned it. It's a system with steam and water all at the same time. Besides in a temperator, it's really the only place in a plant that you mix steam and water in a high pressure piping system.
Dave, we've got everybody sitting up a little bit taller in their seats. And so now, without going into grave detail, roughly how much is that valve worth, that one valve?
Dan, I'm going to let you answer that.
Yeah, that one valve could run you probably anywhere between $280,000 to $400,000.
Yeah.
And a 2-week delivery?
Larry wants to know if he could get it in 2 weeks, Dan.
2 weeks. That's a little tight.
Maybe 3. Maybe 3 weeks.
Delivery times. These are generally handled on new construction bases. Is that a word? Handled on new constructions, and so delivering of a combined cycle power plant is like a 36 to 42 month cycle. So these valves here generally are about a 40 week lead time.
Yep, that's what I saw. Let people know.
Yeah, we're just setting the stage for the guys. Like I said, these are big projects. They take a while, and they're high dollars.
Yep.
It can. And we have great relation. I can say that we just replaced some competitor bypass valves, both on the high pressure side and the intermediate side at some plants in Mississippi. I'll say that 2 plants. And, because we had other product at that plant, we obviously were working with the plant guys way ahead of time to meet their outage. So even though these lead times, like Dan said, are long, for the type of work that we'll be doing, we're always making sure that we're working to some outage that they can meet.
Yeah,
especially on the
essentially, you can imagine when you're having to cut grade 91 piping and that sort of stuff. It's a big job, and so the replacements Dave's talking about usually requires some sort of budgeting approval process, and so they generally start relatively early on in the process.
Dan, whose valves might we be replacing in the field?
Emerson, Mason Nealon, Leslie, Velen and Tucson.
Okay.
That's exactly what Ben said. I just challenged him. I didn't think he was right.
Yep. Thank you, Dave.
I think I might be getting tight on time here. So
yep.
I'm going to just make a quick comment about another tough application, a temperation. It's got some of the same problems that turbine bypass does of high pressure drops, high steam flow. And the temperator, and this is very small, but it's located in between different heating bundles within a HRSG. This is the HRSG right here, okay? What the temperator does is it sprays water at different stages in that HRSG, quite frankly, to protect the material, to keep it below the design point that the HRSG OEMs decided, your Neuters and Boats of the world and all those guys. This metal right here can only take so much temperature at a certain pressure, and so you might have to spray down during transients and start up. So
Dave, back up one slide if you don't mind. There you go.
Yeah.
The pie chart. Tell me the pie chart.
So this pie chart, again, it's a little bit old. These are combined cycle plants, so this is not any data on CHP or other things. Basically, what this is showing is that where we have supplied different, and I have everything here, not just the temperators, but a temperator systems, the number of plants, turbine bypass, which I already mentioned, feed water regulator valves, and recirculation valves. So this was an install base from 2002 of 2016 of these 4, I'll say maybe core IMI power applications. And that's why I was saying earlier when Jeff and Boyd were showing and naming plants and in utilities, I was shaking my head like, yes, 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 yes. I mean, we're pretty much everywhere that they are.
Thank you.
Okay. So again, really just one slide on the temperators. You're trying to protect the HRSG from cooking the pipes. You also don't want to spray too much water and quench the pipes. There's sometimes the temperators outside the HRSG that are located right before the turbine. You cannot send water into the turbine. I think Boyd mentioned that. So temperators have many of the same challenges as bypass: high thermal shock, high pressure drop, noise and vibration, and accurate controls. So just to put a little bit another point to it, imagine this is just a piece of pipe. These temperators sometimes sit for long periods of time doing nothing but being a piece of pipe. So you might have 1,050-degree steam flowing through here, and then there's some kind of transient or power shift in the grid, and they've got to run the gas turbine differently. Things heat up, and you've got to spray some water. Well, this has been sitting for maybe 6 hours hot, 1,050 degrees. Now come and spray 300-degree water into this piping system and hope nothing happens. So it looks like a very simple piece of equipment. It's not. So we'll talk way more about that when we do more training. But a temperation, if it's not done right, and this is my key point, it gets blamed for a lot of stuff. I mean, you can go online and Google a temperator, and you'll see all the Power Mag articles and everything about all the problems that everybody blames on the temperators. They take a lot of heat. And because of that, we have to make sure we design them correctly so the finger doesn't get pointed back at us. The point is they protect some pretty expensive equipment in the plant. This is just a cross section. I'll skip this. I basically went through it. It's just basically showing a system of a control valve with some kind of a temperating device to control the steam and the water injection into the steam. I'm probably short on time here, huh?
You're a scooch over, but don't skip. If we go 5 minutes over, it's not going to kill us.
I've got just a few more slides, and basically it's just one slide each to highlight, just to get the applications in your head. Another big application for us is the boiler feed water, or what's called the drum level control. This is the valve, very important, that controls the water that goes into the drum, and the drum is where saturated steam is made. Boyd talked about it a little bit from his point of view. From our point of view, this valve is absolutely critical because it's protecting the drum and equipment downstream of the drum. And one thing that makes this valve hard to design is that it has to have a very high ability to control a big pressure drop from plant startup, and also very high CV ranges. So the valve has to have a very high range ability at a very large change in pressures. Sometimes you need 2 valves to do it. Often you can do it with 1, but a very critical valve that we supply quite a few of. The other one is the recirc valve. These valves are protecting a very expensive piece of equipment in the plants, which is your pumps. So basically these valves supply a minimum of water back to the pump, so you don't cavitate and have issues on the suction side. They have to do a lot of things like control a very high pressure drop, usually the highest pressure drops in the plant. I mentioned one earlier that we're looking at that has a 6,000 PSI requirement. It also might have to require MSSP or very tight shutoff. High chance of flashing and cavitation. So these are very severe service valves. This is another one of our important products. Last one real quick is vent systems. I mentioned this one too. A vent system, depending on the plant layout and environmental concerns, sometimes you may take steam and instead of bypassing it back to a condenser, you may have to vent it to atmosphere. It really depends on the plant operating regime. And the system is usually some kind of pressure reducing control valve and a silencer. So we design both of these, the valve and the silencers. We design our silencers out of a facility in Kansas, in Winfield, Kansas. Same thing though. Look at the challenges I listed over here: thermal shock, noise, tight shutoff. You kind of start seeing a common theme here that those are the major problems that we have to tackle. And I think I'm just gonna, I know I'm over, so I'm gonna say one last thing, as I mentioned it earlier. What we're doing now, and I think this will become its own training module maybe, Dan, is retrofit. We've been retrofitting valves since the mid-70s. Now we have a new business unit actually to start doing it more aggressively, and it's all because we're using more additive manufacturing. And we can cut lead times down significantly. So instead of an 18-week lead time for a trim, we can do maybe a 4-week lead time. You don't have to send as many, there's not as much process requirements for documentation and engineering drawings when you do 3D printing. You can send a 3D model directly to the 3D printer and they can make the part. So for many reasons, there's a lot of time taken out of the manufacturing method. And one of the main things we do is if you've got a problem at a plant with a valve, maybe it's a competitor's 3-stage cage that just didn't have enough pressure control, we will analyze the customer's data and say, you know what, instead of 3 stages of pressure control, they should have had 20. We're going to go in, take out the customer's trim, and put our trim in their valve body, leave their valve body alone. If it's welded in, that's a great selling point. And we're going to put our trim in there. And we've been doing this, like I said, with older manufacturing for many decades. We've just moved to the 3D because we can do it faster now. And I feel like I was talking really fast, but that's all I had.
Thank you, Dave. We do have a handful of questions. If it's all right with you guys, Boyd, I think you're still with us too. We're going to shift the agenda just a little bit. We're going to go ahead and answer questions now, and that way we can let the partners move on with the rest of their days. So Nikki had a few more questions. I think the first few are going to be probably back towards IMI right now, right?
Correct, yes. So the first question is, retrofit 3D will lower the cost to move to CCI drag. Love it. Okay, that was a comment, sorry. Thank you, Paul. Next one, best illustration I've ever seen combined cycle flow chart. Thank you, Jay. Okay, next one. Are those numbers in the pie chart all IMI critical, or does that include other IMI divisions?
So I heard the first and last question. I'll go with the last one. That pie chart was IMI CCI, because that chart is a little bit old. That does not include the other IMI critical brands.
So it's just CCI. The other ones were compliments to the presentation. The first one and the second one were compliments. They actually weren't questions.
They thought you did a nice job, and we'll buy you a beer next time we see you.
Yeah, if we ever get to travel again. And hey, I want to make a comment about that. I don't know if I mentioned it. Normally in non-COVID times, another part of my job is I would be out if you need support at a site. I would be the person that would be out there with you doing the walk down, me or my boss or a few other guys. So once things kind of get normal again, that's probably something that Dan will talk about a little bit more. But part of the service is to be out there to help you ask the right questions and look at these valve problems.
All right, so guys, you're welcome to stay with us. We know we kept you. Okay. Sorry.
Do we have any other questions,
Yeah,
Max?
I'm sorry.
So how common is that 3D printing in the industry, and what is the customer buy-in been to a 3D printing manufacturing process as opposed to standard manufacturing?
Dave, I'm assuming you're able to hear that?
Not too good, actually.
They're just kind of asking about how common is the 3D printing in the industry, and how widely accepted is that from the customers? Has there been any pushback on the 3D printing? I got to imagine it's going to still go back to material construction.
Yeah, so actually we have, there's other people doing it. We're not the only ones. And if you think about it, they're 3D printing turbine blades for both land-based turbines and blades flying around. There's compressor heat exchangers on gas engines that are 3D printed. So there's actually 3D printed parts that are in technologies, I hate to say it this way, but way more advanced than what we do. So, yeah, I would say the industry's doing it. I know for sure all the big gas manufacturers are already 3D printing, like I just said, turbine parts. Now, as far as valve trim, no, we've got good traction. And let me go back. About 10 years ago is when we first started printing with the particular 3D method for our spray water valve. Yeah, it goes back 10 years. We've got hundreds of those installed. It's got the benefits of, like I said, a quicker lead time. We can actually package more velocity control in the same volume than you can with existing manufacturing methods. So there's no negative feedback in the sense that anyone's, I'll say, skeptical of it. Pretty much everyone's been on board with it.
So
and,
Dave,
it's not just.
Go ahead.
It's not just the disc stacks. I mean, there's now pressure boundary you can't do yet. ASME doesn't recognize centered or powdered, or I should say powdered metal, but they're looking at it. So to go back to your point, even the code guys are understanding that they need to start getting these powdered metals somehow specified in code so people can start making parts out of them. So right now, we're only doing the trim parts that are we get to design for sound engineering practice, and we don't have to get, we don't have to design for code. So that's why it's mostly on the inside of the valve now.
So the biggest thing when I think valve and 3D, not anything about what you talked about at all, but valves are heavy as shit. Are you 3D printing any plastic valves for these guys when it comes to trim or whatever to be able to bring around? And we already
talked about that. Yeah, Dave wasn't involved in that. Dan is.
Yeah.
We're working on getting a 2-inch 3D plastic valve at some point for the offices.
Okay.
And we're going to have some, Dan, correct me if I'm wrong, but we're going to have some, I'm going to call them discs that are going to be like samples for the guys that kind of demonstrates the drag technology.
Oh, Dan, you're muted.
Dan, you're muted.
Did you unmute Dan?
The other Dan.
Dan Marquis.
Marquis, you're muted. I don't know if you can unmute yourself or not.
Now I'm unmuted. I was unmuted on my end. It was done by the organizers.
There you go.
Yep. So yeah, no, it is something that we're looking at. We do have some 3D printed models. Dave was holding up one, which is a basically printed nozzle assembly for our temperators. We do have the disc stacks that people can take around to show the torture's path. People can hold the disc stack, not the disc stack, but I'm sorry, the individual discs. And then, we do have some models that are that have been manufactured. We just got to find out which of the sales guys will part with them. So they're rather costly. So I don't know, maybe now the prices come down more reasonable level, and it's probably something we need to look at a little bit more.
Okay, thank you. You had 2 more questions, I think, Nikki.
Yeah, actually I have 3 more questions now. First question is, do you entertain other manufacturers, electro-pneumatic positioners, where they have someone else as a standard, or do you always stick with our internal controller?
Yeah, you could put anybody's actuator on your valves. Position.
Yes. Yes.
Yes. Yep.
For everybody that's listening too, I'm sorry, Nikki, but for just everybody that's in the room, obviously y'all can see Boyd. But for whoever's else online too, Boyd's still with us too. If you got questions about E&H product, Boyd is stuck around with us. And if we got thermo questions, Brian Sullivan's with us. So any and all questions at this point. Sorry, Nikki, what's next?
Okay, next question. Have you had any success?
So real quick back, just let me do what Dan said, yes, on the actuator. It just takes a little bit of interaction between our engineering department and the actuator OEM's interface so we can connect them. But yes, we do that quite a bit.
Thank you, Dave.
Nikki?
Okay. Have you had any success with SWEPCO plants, now part of AEP, traditionally a low capital cost vendor with lots of spending on repairing Fisher valves?
Any success stories with SWEPCO?
Conversion.
Used to be AEC?
AEP.
AEP, sorry.
That's that Arizona Electric. I'm thinking I know them in Dayton.
American Electric Power is who I'm thinking.
American Electric. Yeah. Dan, I don't know if you know of anything recently, but I'm going back in my history.
So Dave, let's hold off on that. We're going to be providing everybody with an existing, where their business has been the past few years, what are their core customers, and then targeting. We'll be talking about specific customers later.
And
What other questions?
we
do you
have that data.
Yep.
Paul confirmed it was Southwestern Electric Power
Okay,
Company.
no
That was
big
the
deal.
question.
Yeah.
Okay. Next question, is the powdered metal only used in between the disc to center?
Are we only using the powdered metal between the discs to center the discs together, or is it actually?
It's actually a brazing film. So when you have the what's called the EDM stack manufacturing, it's a thin film that gets layered between the stacks. It's not a powdered metal. The powdered metal.
Good. I'm sorry, Dave. I was just gonna say that too. We'll cover when we do deeper product training.
That's getting down in the weeds, guys. Good questions. Great thoughts. But I think we'll get into the weeds a little bit more when we get into detail.
Right now, we're trying to talk about general applications within the power and energy sector.
What else?
One last question from James. What about nuclear power? I have Matt.
We're not focusing on nuclear power. We're looking at fossil fuels.
Yeah, today, guys, we could have gone into wind power and 9 other types of energy, IMI specifically, as well as, they have a specific area of products geared at the nuclear industry. ENH, you could say, has some no end stamp stuff. We know about that. Today was hitting 80% of what's out there. We know we have a good install base, good background, good resources. Let's go there. And we'll talk about some of the other power and energy opportunities as we move forward.
Yes. That's all Nikki has. Last chance, guys. We still got Boyd with us for ENH.
Did you unmute everyone?
Hey, I do have one comment actually myself. I think one point listening to Dan and Dave, when you're talking about the control valve going into the steam drums, it seems like we have a really good opportunity there to have a full package solution for both the instrumentation and the control going in there. And that's a real, it's a touch point in industry, right? That's where people are having trouble. It seems like we should be able to make some hay by going in there together and bringing a whole package.
Yeah, and Dave and Dan, that's something that even plants that aren't big Intereson Hauser users, they're big Emerson, Rosemount, or Fox or whatever. That's an area we've been able to get into plants because of some unique things. We have some patented technologies for measuring the level in that drum accurately and then giving that feedback to your valve. So yeah, I think we have a nice package there. We can do a little.
There's that, and the measurement of the steam quality. The measurement of the steam quality too would be, I think, is a good complement, right? If you can combine that,
Got a lot of reasons. Yeah. No, that was the goal of this thing, and bringing all you 3 partners together with us today is because of how intertwined your products are, and it really gives us a solution to bring out to the customer. So Larry and I are already going back and forth on a few of these topics, so it's perfect tie-in there, Boyd.
I have 2 interest questions.
Okay, 2 interest questions for Boyd coming up, and we'll let you go.
First question was, can Interest provide a trial unit for sodium or silica analyzers?
That's more on us.
Oh.
That'll be on us working with our local regional manager. The answer is yes, we've done it already. I don't know, Wally. We've done it already locally. We're able to do it. We just can't say we're going to give you 10 silica analyzers. Let's work on a case by case basis.
That is a good point though, because one of our selling points there is ease of operation, and it's hard to see ease of operation without seeing the unit, right? It's hard to put that in a PowerPoint.
Easy for you to say, Boyd. You want to help me fund it?
I know.
That changed real quick. Yeah, boy, you did. That's a great idea. Okay, who's gonna pay for it? No, we'll work on that. Whoever that is, have them send me a note.
All right.
What else?
One more, Nikki.
The other ones were all
Okay. More compliments for the presenters.
You're a good-looking group. 2 of you need to work on your haircuts.
Gentlemen, I can't thank y'all enough for your time. I know a couple of you had to get up extra early this morning being out on the West Coast. But Dan, even out on the East Coast, do appreciate you getting up with us.
By the way, guys, we're dropping you off, but we want you to know we're continuing with our team specifically to talk about IIR data that we've already mined and qualified. And we're going to be giving all of these guys project opportunities. Now, we know those are long-term. We know these are 2 years out, but we also are giving them turnaround and shutdown information. So we're going to be working with our services team. There's got 20 guys in our service group. So we're going to be working with them to target some of these turnarounds to identify some of the shorter term things, as well as stuff that you guys are already working on that we can help each other. So we wanted you to know that we're going to continue with this group.
Hey, they said something about, our install base or whatever. They have an ABL as well, like a list of where they approved that in regards to.
Yes, and we have an install base.
Well, we know we're going to give them the install base, but that's a little different. Do y'all have, and I know we have it from Boyd at E&H, a list of where you're on the ABL as either preferred or accepted, and with whom? And Dan, that's more for you.
When it comes to the power side, we're pretty much on every AVL.
Every ABL.
So
They're pretty much a standard in power.
They are.
Yes. Yeah, when you start talking about critical service valves, for the most part, you will find 3 or 4 vendors on there, because there's really only about 3 or 4 vendors that really do this stuff well. You find a few others that may come in from Europe, but they're not, it's kind of hit or miss. They kind of follow the major projects, that sort of thing.
Dan, is it safe to say we ought to find IMI or CCI on probably 80%, 90% of the AMLs out there in the chemical plants and refinery market for?
On the CCI side, yes. Okay. IMI, we went through a rebranding about 6 years ago, 7 years ago. So IMI is just starting to come into the play more. And we are now bringing all of the sister companies together. So now you'll start to hear more about IMI critical engineering.
Yep.
As opposed to just individual brands. But right now, if you go into the power market, CCI is going to be well known. Yeah, talk about IMI, they might just say, not sure. On the refinery side, CCI not so much. You will find some IMI, Zimmerman and Janssen, Ramosa, some of our sister companies. On the LNG side of the business, CCI, yes, along with Orton and TrueFlow. We do a lot of cryogenic stuff, a lot of anti-surge, compressor, anti-surge valves, that sort of thing, major valves there.
Okay, perfect.
All right, do y'all have any questions for us before we let y'all go?
No.
Dave, I like your beard. Wait, can you see me?
Okay, so we're going to modify the agenda a little bit, and we're not going to do the answer and question period at the end.
Yeah, that's what I say. We
That's
just
what we're
we
doing now.
kind of shoved that forward so you guys can move on with your day, and then we'll talk about Salesforce and our marketing plan and all that's. No point in tying you guys up on that stuff.
Okay, I can go finish getting dressed.
Yes, sir. Put your pants
Okay.
on before you stand up. Thank you, guys.
Bye,
Talk to y'all soon.
Thanks for the opportunity.
All right, thank you.
Yep,
Thanks for your time. Thanks.
Right, so can we take
Vector folks, stick around. We probably only got 5 or 10 minutes.
Okay.
You're gonna lose them for 15 and get them back to 10.
I'm just trying to, Nikki, you want to drop Dan, Dave, and Boyd? No, Dave's not.
He's trying.
All right, now can the
Can you-
rest of the
can-
team see Dan Abrams?
Sure.
I can see Dan. Hang on, I got it.
It's like he's
Yeah, he's on, you're on the.
I'm like a ghost.
All right, so the issue is I can see what everybody sees here, Dan. This is what I. Okay, do you want to go first then, Nikki? You want to come up? Because right now,
Yes, I can, but go back one slide again, please.
how do I do that?
Hey, I don't know.
Go
That's,
Page up,
man, don't start this again.
page up.
Larry. Page up doesn't do squat, brother.
No, you're still on the same one. I can't do it. She want to know your microphone. Right now, we're on this slide. Oh, you got it.
Oh, how do we get there?
This is my second.
Did I do that?
You're going backwards.
Oh, my bad.
There we go.
Oh, oh, hey,
One more, go forward, one more.
I'm scared to touch it.
Okay. All right, so let's talk about marketing quick. I first want to say that the team has really put a lot of effort and energy and time and really thinking through this. And even though we had a lot of glitches today, that is not exactly of what really this program is all about. So I want to apologize for the technical difficulties. We will get better with that. But from a marketing perspective, this is what we're kind of looking at for moving forward for the now through the end of the year. So we have printed marketing materials. All of you have gotten a launch kit box. Those of you on the phone, a box was mailed to your house. You should have received it. Those of you in the room here, your box is in front of you. It has 50 copies of our new Vector Power and Energy Solutions brochure. I think you will find that to be very useful in sharing with your customers. The team here internally took a lot of time thinking through that and developing a piece that we felt was really educational. So I hope you like it. There are more of those in literature fulfillment should you go through all 50 of what you have in your box, okay? Those of you on the phone, same thing. You have your box and your hard copies of the new brochure. Additionally, there is a few pieces representing each of the 3 companies that presented today. So Anderson Hauser has about 3 pieces in there. Thermo had 4, and I believe IMI had about 3 pieces in there as well. So just one copy of that, just for reference. If you need more copies of that, if you're here in the room physically, there's extra copies in the back of the room if you want to take any. If you're on the phone and you want more copies, you can send me an email and I will get them to you. Additionally, we are going to have a Teams folder where all of these items and much, much, much more will be available electronically. I am in the process of creating that right now and finding the best location for that on Teams. And then I will send a link out to everyone to let you know exactly where it is and make it easy reference for you. Additionally, as you know, when we put things on Teams, it also goes on SharePoint as well. So we're still using that, and you will have that for reference as well. Our hard copy brochure is also available for download on our website, along with our other pieces of Vector literature, as well as if you go to literature fulfillment, you can always download it, electronic copy there as well. Additionally, we're going to be having a series of LinkedIn posts that you will see throughout the coming weeks, and we will do a series of e-communications. Those I will not do every week because not everyone wants to get an email, of course, every week. The LinkedIn posts, you will definitely see more of that. But I will be using the list that we have gotten through the data from E&H. So once we have that list, and that's a nice customer list, I will use that for e-communications. And there may be some other things that come up. You know, if you're out visiting a customer or you see something that you think is good for us to be using from a marketing standpoint, let me know so we can add that. So you see here, this is just a few of the partners that fall into the powering piece. Of course, we have the powering your success. That's kind of an internal theme, but it kind of goes external as well, right? We want to be powering their success. Okay, Dan, how did you fast forward?
Don't advance yet.
Okay.
No.
Only because on this slide, you will see, yeah, we had 3 presenters and it was hard for us to decide which 3. And I think if you sat back and watched, they were 3 damn good, powerful, hey guys, we got a lot of things to offer, and you should walk in going, we're strong, all right? But there are a lot of other pieces that aren't minor. So on this, if you see there are a couple more, like Eaton has power brochures specifically for power plants and what they can do in control rooms and in DCS systems and things like that, and UPSs. Curves, one of the biggest single things Kerr's ever did is when these power plants were converting, and Blair and Brian have a ton of experience with Gene, sold millions of dollars for the K-bars. How would you describe a K-bar? A multi-point flow array. Thank you. I knew there was a word for it. Guys, they are strong in the power industry. They know that market, and they have something that is unique that nobody else does. And that's what you want to know about. So before she got off this slide, I was like, ooh, wait, Universal Analyzers with the SIMS packages and everything that Universal offers for the analyzer side of things, know that these guys play in that market. They're strong in that market, and they have great products that fit the power market specifically. Who did I miss? SICK on SIMS, not just on SIMS, but on, you know, those huge cooling towers that you see at power plants. Some people are wanting to measure the flow. How the hell do you measure 100-foot flow out of a huge tower? SICK can do that, but SICK also can do a lot on the SIMS side. So these are some of our core companies. Solaire, we know everybody's got a compressor, everybody needs a dryer. So every power plant, you go in and sell that. So every power plant has at least a few, not one, at least a few of these that you can go in and feel strong about. They aren't included there, but they are included on this new power and energy section in Teams, all right?
Right, and that's a good point in Teams. So not on our new piece of collateral. Our collateral, our brochure that you guys have 50 copies of right now, that leads with the Vector brand only. We are not referencing any of our channel partners in that piece for the reason, lots of reasons, but one being lead with the Vector brand, but there's lots of different areas that fall into what the solution could be. Okay?
Thank you. Sorry to interrupt.
You always interrupt. That's all right.
But I'm sorry.
Okay, how do
I think just either right or left.
here? Okay, and this is just a quick slide that kind of shows what you're going to see with some of the pieces from a marketing perspective. So keeping in with the Vector brand and our look and feel of some of the templates. So some will focus strictly on our partner. So this is where you will see the partner information, you know, with LinkedIn, with some e-blasts, might be product specific. So that's just a sampling of what's been done. Additionally, Anderson Hauser has already done a few of these campaigns, so I'm working directly with their marketing department to be able to share some of the other campaigns that have been done across the country with some other rep agencies. So you'll see some product specific information from them, and I'm going to use that as kind of a template to work with our other partners then to develop those types of things in more depth. And that's all I have. Any questions for marketing?
You only have one more slide, right?
Pardon? Yep. Teams.
Is there a power? There will be.
Not yet. It's coming.
It's going to take me some time to create it. I'm hopeful to have it ready by tomorrow, and I'll send it out.
You're gonna put those PowerPoints.
All the PowerPoints, everything's going to be there.
Yes.
And the only thing holding us up is we're trying to get the hierarchy right to where it's Teams doesn't turn into a mess. But yeah, the PowerPoints are going to be there for you guys to go back and review them, which I would encourage you to, because a couple of guys had to go a little bit faster, and people like Boyd had just a great amount of product knowledge in there, industry knowledge in there.
So, and if you paid attention last night to the presentation, that was more of an overview presentation. So we will be working, and we need y'all's input on this. If you're putting together a lunch and learn presentation and it's around these two and you're vectorizing it, make sure that you're working with Nikki and your team here, because we want to share that. We want to share that collateral with everybody on the team. We will come up with a good lunch and learn presentation, an overview presentation on our power capabilities. That'll be in that folder, okay?
Besides the lunch one, we do need like a single slide on this to put into the Vector overview.
A single slide on what? What?
On this power version.
Just a water, like we got a water wastewater slide, just in a vector presentation.
Yeah, the Vector.
Oh, yeah, that'll be something Nikki will need to.
Right. And as so you may have noticed with the PowerPoint, so we kind of have a new updated template. So it is on my priority list to get a nice overview presentation of Vector done that I can share with all the sales teams for reference. And so that's a great point, Max, to make sure that we have a slide on each of our industry segments. Yep.
To go in our standard Vector overview. Okay, so with that, One thing I didn't bring up as far as products that are geared, if you do not know, remember HydroVision? Never heard of the name, never sold one. I think, Jeremy, you're the only one that sold a few. Their core market is the power market, and it's on large water flows. They'll put 10 or 12 transducers, transit time transducers, wetted, because power plants, that's a real big measurement, and it's a 7-foot diameter or a 12-foot diameter once through flow. That's what HydroFlow cut their teeth on. So GWF is the new name of HydroVision, excuse me. GWF, if you want to grab a brochure, I think even their older brochure, all it had in it was power, and we said we need some water and wastewater pictures. They are known for high accuracy, large water flows. A lot of power plants have large water flows, all right? The last thing, I think, Salesforce.com, IIR, and KPIs. Do we have a slide on KPIs?
That's kind of like a chart, but the actual KPIs will be out by Friday.
So KPIs, that's another acronym. We're not sure what it stands for, but it means we're going to come out with a list of things that you guys need to do, and we're going to scorecard them. If you've seen this, we're doing it in food and beverage. We're doing it in other industries as well. You will have some short-term goals to just some of the ones we came up with. First 30 days, go ahead.
Start filling out the account analysis. I know there's a name for it. And I don't know why.
Identify the account and know the address. I mean, honestly, that's the problem. With as good as all of this is, how many people have been to a power plant? I know some of you on the phone have, because I've talked to you. How many people in this room have been to a power plant in the last 3 months? You have, bro? Wow, that was even special.
That's even COVID time.
Because COVID, yeah. Then I was gonna say, how many have been to a power plant in the past year?
I got 2 more hands up.
Yeah, but honestly, even you guys remotely, I know some of you do, because power is a big part of your business. Guys, this is a whole new endeavor for our company. That's why the team that's been assembled here has been working really for about 3 months. 3 months getting this together. I know it might not look like a lot to you, but there's a lot of collateral here to give you loaded to go in with a couple of guns with some armor piercing bullets. Right.
And we mentioned this yesterday on Salesforce.com. There are highly vetted and I'm gonna call them qualified leads. You know, they're qualified as much as we get. We took what, 1,800 and went through a bunch of gates and got it down to 100, 150, and that's across the entire group, right? The goal was for every one of y'all to have 5 to 10. So you're kind of going, oh crap, I hadn't done a lot in power, and you just threw this thing on me and said, hey, go get it. We put that out there for you. So you don't have to use it.
Yeah.
There's some debate amongst leadership about doing it. I think you're crazy if you don't go look at it, right? Because we're telling you where there's some outages, some turnarounds, some capital projects.
Yep.
We're giving you a few names. You can be argued if those names are valid or not. You know, is that report old? We get it. But we're trying to give you a starting point and prop y'all up with as many tools in your box as you can before we ship y'all out in the field.
It's a phone number and an address. Take the time, guys.
Be the right name, but that number works.
Exactly.
Hey, you're not the maintenance supervisor anymore, man.
Yeah.
Who is that guy today?
Fred died 3 years ago. That's cool. Who took Fred's place? Right? Exactly.
For those that dealt in the power world, you know this. These guys don't get ran over quite as much as like the guys at the refinery down the street. They're usually a little bit easier to deal with, especially when you go in there bringing value. One of the other things I want to make sure everybody leaves here with is, you noticed all the leadership's kind of squished together on this deal. This isn't INA, it isn't mechanical, it isn't analyzers, it isn't service. This is vector. And we really want to make sure we put a lot of energy into trying to make sure everything was covered. You notice 3 presenters, 1 from each division. You know, there's a lot in this thing.
First brochure that's ever come out that doesn't have a logo. Did y'all notice that?
Yeah, and also though, you use our references as well. That actually is part of the power plant. You open it up.
There was a few revisions to that picture, but there was a lot of energy went into this.
Well, there is one typo in it. We don't want to hear about it. Nikki doesn't know yet. We actually noticed it yesterday. We'll tell you about it later.
That's our fault. We know
whoever figures it out, Larry's gonna buy you lunch one day.
No, I won't. Anyway, but yeah, that's not the typo.
That's not the one.
All right, so guys, IIR, the IIR stuff won't get populated until Friday. Guys, if I'm an E&H guy, right? I know E&H pretty well. If I'm driving up to a plant or calling a guy for the first time, the first words out of my mouth are, hey, I'm the CCI thermo guy. you're going to hit 80% of the people you call and you say, I'm CCI and Thermo, they're going to go, oh, really? It's not, you won't drive up and say, I'm the Interest and Hauser guy. They go, ooh, right? So I'm telling you, we are excited about this IMI CCI deal. They were the dominant player. What we didn't say, and I told a couple people, they're off the phone now, so I can say it. A lot of their company had to file Chapter 11 because they were sued by the federal government for dealings with China.
This is like 15 years ago.
Yeah, no, it's years ago, but they had an 80% market share in severe service in the power industry, 80% market share. List price, everybody was making a lot of money. They did some stuff with China or Iran, one of the two.
Or both.
I think it was both, but China is where they got caught. And a bunch of people, no, I'm not lying. Upper management people went to jail. They went to prison. So they had to divest, and that company got completely just obliterated. So they came back, and they are strong. They have a huge book of business that's coming to us. So a lot of you are looking at an additional $500,000, $1 million coming to you. That's between now and the end of the year. It's not going to happen tomorrow. This is a big deal for us. Keep it down. The announcements are coming. But I'm telling you, when you drive into a plant, if you say CCI or Thermo, both of those are highly recognized. It's like if you went to a European chemical company and said Endress and Hauser, they go, oh, I know Endress and Hauser. It's the only place.
They should be the number 2 line in Vector next year.
Yeah.
We have failed miserably if they're not number 2 by a stretch.
So do y'all have a question? Can you unmute everybody, Nikki? We only have our team now, and there's only a few people. We're really tied up now. It's 10:15.
She's back there trying to find a typo.
Okay. So guys, if you have questions, you're welcome to type them in. We've given y'all a lot of information. You will have more links to the team's website and more links to more information. We're going to be coming out with white papers. We're going to be coming out with more technical presentations for you. But guys, study up. I will also tell you the learning portal right now has a power and energy circuit. What do you call it? No, it's a group, but like you have a food and beverage circuit channel. It's called something else. But there is a power and energy curriculum. Thank you, John. There is a power and energy curriculum on the website. All right, guys, hold it tight just for a minute. All right. Because y'all are going to be the 2 I asked to do the power and energy curriculum on Learning Portal. All right, so a lot to learn. There are about 30 modules that talk about different areas of a power plant. There are video modules that you can go through. You can do the ones that take tests, or you can do the ones that are just information.
Damn it, Estridge found another typo.
Did he already?
Yeah, good one, Dave, but not the one we were looking at.
Yeah, all right. We already found 2 typos. Yeah, Nikki's spotted. Did you unmute everyone or not? All right, guys, if you have another question, can you send it to us? If not, we're going to let everybody go. We have to work on getting some orders today. The only negative on all of this is, guys, this is going to be a journey. All right, we're not going to go tomorrow and get $10 million in orders in power and energy. They don't know you. They've never heard of Vector. All right, so even though they've heard of IMI, CCI, and Thermo, it's still going to take a while. Remember, if you sell one of those $280,000 valves tomorrow, you get a commitment. When is the PO coming? Well, the PO might come before that. When is the valve coming? 40 weeks, and you get paid like 20 weeks after that. So yeah, go ahead.
Okay.
Question.
I had a question. Caleb wants to know, this is for Larry. Power Specialties here in Kansas also shows sick on their line card. I thought we were the only rep for their ultrasonic flow and gas analytical.
There's a longer story to that. They are broken into divisions, even with their ultrasonic flow meters. So Kayla, that's a one-off. I will call you specifically because that's in a specific area. So
I'm sure you can get IMI questions. There's going to be a lot more information next week on IMI stuff.
Oh yeah. What else? Anything else from the outside team, the inside team? Y'all didn't ask a lot of questions. We know we got you up early. It was worth you getting up early. Remember, the 2 of the presenters are on the West Coast. They had to get up. They were on the phone with us.
And the third's in Mountain Time Zone, so he's an hour ahead of us too.
Yeah.
So.
There was another interest question from Paul. Of the interest combined cycle gas turbine plants brochure shows what looks like a mag gauge with a GWR shoved into it. Can they really do this?
Oh, absolutely, Paul, and I apologize. If you haven't seen that, we actually had a demo here where we had a guided wave radar on top of a mag gauge. So the answer is yes, we do that now. PLT can quote it as a complete assembly or ENH, so we can quote that either way. Make more money if you quote it as a PLT and let them get the radar on top. Anything else?
There's a few comments from the group about putting together a separate line card for power. We'll talk about that, but I do not foresee that in the near future.
No.
Your collateral for Vector is what you have in front of you right now.
Yep, you have a good overview brochure. Remember, we're selling Vector and Vector Solutions. If you're going in, the guy wants to talk to you about mag meters, you bring a mag meter brochure. And if you say, while I'm there, I want to talk to you about compressed air, you bring a Solaire. It's not saying we never will, but right now, no. The answer is no for right now.
We went agnostic for a reason.
For a reason, yeah.
We should know what our lines are. That general brochure, if you look at it, it's agnostic and it talks about solutions and applications that we can solve. Because if you put, hey, we got blue ones and the customer likes red ones, maybe you never get the call. We intentionally did that. Hey, we have valves and the customer will call you. Got to go, what kind of valves you have, or what brands you have for that type of valve. So there is a method behind the madness. Anything else, Nikki?
We have solutions everywhere. So she had another one, but I have.
One of the questions that came up was, hey, do we have SICK in this area or that area for the analyzer side of things? The answer is, remember, you have solutions anywhere you go. If it's a SICK analyzer in a shelter, it's us. If SICK analyzer with a sample system, it's us. If we can bring it into Vector as a solution, you have every product we have in the analytics side everywhere. Does that make sense?
One last question, you guys may have talked about this already, but regarding IMI, CCI, do the end users know them as IMI or CCI?
Could be either way. Somebody was asking about IMI, CCI. I still think CCI is going to have the most legacy name out there in the industry, but that's why I'm saying know both, right? That's going to be legacy, but they're doing a pretty good job of rebranding everything with the IMI in the front of it. And so if you're checking AMLs and things like that, let's look for both, because sometimes you might find that there's a different IMI brand that's on the AML, and we kind of go, well, if TrueFlow's already there, it's easy to slide the CCI in behind it or vice versa.
And TrueFlow is a good name too. TrueFlow is a big name. Just CCI.
15 years ago.
They've
been back. They've been selling factory direct.
CCI as a name still, right?
Absolutely.
When I look at, so they do the same thing for Raychem. A lot of times,
Exactly.
Raychem is the.
Yeah, you don't let that name die. They keep it alive.
It's in that Raychem, but yeah, now.
There'll be a lot of training that's going to come out on that. There's going to be a lot of information that's going to come out to support that. We know where they have install base at. We know where they have open opportunities at that they're going to be rolling over to us. Starting next week, you'll start seeing a lot of information. There is a select list of those. We'll go over it later because we're still negotiating it down. So this has been going on for months too, and every conversation we have with them, that list gets smaller, and the goal is to have it eliminated pretty quickly. So
Give us a few months. We'll talk about it more next.
There's a lot going on there. We'll get it.
Where's CCI?
Most of the corporate folks are out on the West Coast. They got people in Atlanta. Dan works out of his house out on the East Coast, but there is a massive facility up here on the north side of town, just short of the airport. I don't know, Larry, that place is 100,000 square feet plus. The big 7-foot tall valves and shit they're working on. They bring them in there and remanufacture them, work on them, service them. They've got big trailers of equipment. When we're looking at these power outages, they'll bring a trailer out to a field somewhere, and they got drill presses and repair equipment in the trailers. There's a lot, and what's good and bad is it's two major initiatives that we're rolling out once, power and the IMI partnership, but they kind of control the power market. So that does kind of help us that those two things line up for us.
They have 5 tractor trailers that they'll pull into a plant to do a turn.
And they're talking about adding to that fleet.
Yeah.
So it's awesome for us, right? We're getting in the valve business. We don't have to have a valve shop. Yeah. All right. Any other power questions?
Go get a power PO today. Power starts with PO.
He just thought it out. He is so happy. Thank you guys, everybody that's online, for joining in.
Please grab a Galati. I'm about to bring it out to the inside.
So they're not on Valero's email.
Are you sure?
I had it right now.
Jared has already had some conversations with some of his buddies over there.